Okay. 1, 2, 3. Wow, great. Okay, tell me when to start. In 2 minutes. Yeah, 1 minute. Okay, we have several seconds before I start. Okay, I'm Boris Weisman. I'm Vice President of Tech Users Group. And the reason I'm here is because our president, Artur Rosendahl, just a couple of weeks ago had his second son. So I would start with congratulating him and best wishes to him and his family. Now, now we are starting this conference in Prague. I would say that Tech and Czechia had a very long and happy relationship. Years ago, Czech dissidents used Tech to typeset their materials. So, as I always say, that the revolution in Czechia maybe was not televised, but was beautifully typeset. On the other way, Tech really got a lot from the participation of Czech people. We had, they pushed multilingual Tech, they pushed a lot of other development, so Tech got a lot from people here. And as Johannes reminded me, it's exactly 2 to the 5 years since the famous EuroTUG conference in Prague, which changed a lot in Tech. And he is, by the way, thanks Peter for his copy. This is a beautifully, beautifully typeset volume of proceedings. I think I think we have some extra copies of it, and it's really rare and beautiful book. I don't know whether this conference will be as influential as EuroTUG 92, because it's very difficult to be as influential as that. But on the other hand, we have a lot of very interesting talks, a lot of great people coming here, and I wish everybody interesting time in the great city of Prague, and I hope it would be good for us and good for Tech. So the conference is open, and I will give mic to Johannes, who is the chair of the first session. Thank you. I have one. I have one in my... Thank you. Okay. There is a mic also.
So, thank you, Boris, for opening the conference. Then we'll start with the first talk, which is pre-recorded by Norbert Preining. So I expect that the video will be started. And I understand that Norbert will be available by Zoom at the end of the talk to answer questions.
Hello, everyone. First of all, I want to thank the organizers of the conference to put everything in place. I have organized myself a TUG conference, and I know how much work it is, thanks to all the local team and the organizing team. I would love to have been in person in Prague. Unfortunately, due to various circumstances, I had to cancel my in-person participation very shortly before the conference. That's the reason I'm pre-recording this now. You probably won't believe it, but I made it through COVID without ever pre-recording any video. So well, now this is my first time. I think this is take 15 or something on this video. Okay, so I'm Norbert Breining. Most of you have seen me or heard me talking about Tech Live in the last TUG conferences and other tech-related conferences. Today I also speak about tech, in particular tech and Tech Live at Archive. Archive I recently changed jobs, and since a few months now I work at Archive, which is Cornell University in the US. So let me start with what is Archive. Archive is a preprint server, so we provide the website with a lot of scientific papers. Most topics are, we don't cover all topics of research in the world, that would be not reasonable, but we cover physics, mathematics, computer science, mostly these three. There are a few more categories, but not get into details. So it is the world's oldest and largest scientific preprint server. So we started in 1991, this is quite some time ago. At the moment, we probably already house more than 2.5 million articles. And the submission rate is growing, not surprisingly. I also have to say Archive is not the only preprint server. There are a lot of preprint servers out there. Recently I just met the J-Hive, the Japanese archive team. There is Biomed, there are several others out, but within this huge group of preprint servers, Archive is definitely the oldest and biggest one in amount of downloads and in amount of papers. So what's the importance of Archive in math or in science in general? So first of all, that a lot of cutting-edge research was first published at Archive. A few examples are large language models by OpenAI and DeepMind, the gravity wave research, which got Nobel Prize in 2017, and the Poincaré conjecture, the proof of the Poincaré conjecture by Gregory Perelman, for example. They were all first published on Archive. And while most papers end up in the end in some journal, there are some fields where the research often is made exclusively on Archive. So why would authors opt to send their work to Archive and then afterwards sending it to journal? Well, there are a few reasons. Of course, first is the faster dissemination of the results, and and related to this is asserting prior authorship, right? Who has proven, who has shown this kind of thing first is something important in the scientific cycles. So at Archive, we try to be very open in all we do. We just recently released a yearly report for 2023, which includes, besides, of course, the usual financial statements, also how our governance work, how we do work with moderation, a lot of details. So if you're interested, please visit our website and grasp that one. What I want to talk here is about open in a technological sense, in some sense. So open science, open source, and open access. I put open access under quotes because it's not the open access I meant here, the one from open science. It's more about improving accessibility. I will talk about this in a different talk tomorrow, I guess. But the other things are. So open science, what does it mean? We have no paywall. There are a lot of publishers who put the published research articles behind the paywall, quite expensive. And that is getting more and more criticized. Lots of research is funded by state agencies, and then the research disappears behind the paywall. So Archive has been open access to all articles from the very beginning. And in addition to this, also the sources of most articles, not all, of most articles are available. We have about 90% of our submissions are in tech, of those most in LaTeX, and of those all the sources are available. That's a shout out, a big thanks to Paul Ginsberg and all the founders of Archive, who insisted from the very start that authors and scientists submit the source code for the papers. The other thing is open source. We of course use a lot of open source. We also produce some open source. I'll come to this later. But for what we use is We use TEG typesetting system, not surprisingly. You might be more surprised to see here that we still have TTEG running and of course TEG Live. I will come to this later. And the other big part is LaTeX ML, which converts the TEG input files to HTML. This again, as I mentioned, is a second talk I will give tomorrow. Yeah, the OpenX is a separate talk. So what's the, let's put it, big elephant in the room is that we have TEG documents from over 30 years. And all of them needs to be compiled at times. So, as I said, we have 90% of our submissions are in TEG. Recently, I think by far the majority is in LaTeX. But we consider the generated PDF data to be, so the generated PDF file to be generated derivative data in the sense that it is not considered important to keep it because we can recreate it at any time. There's one problem with this recreation of our data, that many submissions rely and still rely on additional packages that Archive came to provide over the years. These are mostly packages which have never been uploaded to CDAN, which have not made it into TEG Live or TTEG back then, mostly because redistribution is restricted by the publishers or it's very local for internal. So we have collected those, we can collect and keep, to make it easier for authors, not that they don't have to upload certain class files, certain conference proceedings, certain publisher classes that are commonly used. Well, and then another problem, which everyone who has worked with a lot of TEG files is probably well aware, there are a lot of concoctions authors can come up. I include myself here. I tested a few of my code changes with my own papers and just realized how badly some of the things I write in TEG work with it. So, as I said, we have to keep these documents compilable. So for that, we keep several TEG installations. In fact, we have TEG installation. We have TTEG 2 and 3 running. I just recently had to fix something in TTEG 2, which I think I have never touched in my life till now. I think when I started packaging TEG, TTEG 3 was the standard in Debian, and that is many years ago. So TTEG 2, many of the configuration items are still very different, and so I had to look a bit around. But yeah, for TEG Live we still keep 2000 at the moment 2009, 10, 11, 16, 20, 23. 24 is coming, 25 then, or hopefully also soon. So we keep a lot of these old TEG distributions around. And then compilation is done, the compilation is driven by a program called AutoTEG. So what is AutoTEG? AutoTEG is a Perl system that was developed since the beginning of Archive, so more than 30 years. It is very tightly coupled with the submission process and actually kicked off by the web server. It does a lot of magic, let's put it this way. It does auto-detection, but, well, not real auto-detection. It just detection of or rejection of some formats in the sense that it reads a few lines, I don't remember, a few lines, like 10 or 15 lines from the TEG code and checks for certain lines that reject certain formats. Like, for example, if you have a document class in there, then you cannot run plain TEG and these kind of things. After that, it just runs all the options. Actually, we run them all first with LaTeX, so where hyperref is already preloaded. Then we run it with normal LaTeX, then with PDF LaTeX. And so the first successful run wins, and if it produces a PDF. For LaTeX, these runs are repeated a few times until stable with respect to references. For plain TEG, we just keep one run. And for some of the submissions, there might be multiple PDF files, there might be multiple input TEG files, there might be additional PDF files that are added. All of those are then put together by PDF pages. So the PDF page is LaTeX package file. where we include the pages into the new document. So what are the shortcomings of the whole system at the moment? Well, the biggest one and the most often requested one is support for LuaTeX or XiTeX, not to speak of any other languages like Japanese typesetting engines. So that is a big one, since it is not that supported at all. The other one, which has been in place since the very beginning, is that we don't support running BibTeX or Biber. So that means that BBL files have to be uploaded together with the submission, so all the files. This makes things on our side much easier, right? We don't have to switch programs and do more runs, but it is a constant problem for authors. Of course, also no support for make index in the same line. Then they already mentioned PDF pages, so if you use PDF pages to combine several PDFs, then hyperlinks from the hyperref packages get broken, so they just get lost. The reason is that if you use PDF pages, annotations are not included, and then the link targets are missing. And sometimes this is also a problem. Detection of the main document is incorrect. So what authors do, they have one directory, they have the class file there, they have an example for the class file, like for blah blah publisher class this and that. There is a sample file how to code, and then they have their own contribution, and then the system detects two LaTeX files, both compile. One maybe has errors, the one originally from the author. And so sometimes the one that is actually a template file is picked. This is a problem. Another problem is archive watermarking. So we put normally on the first page a watermark on the side, like archive, the archive ID, and the categories. And this is a bit fragile at the moment. Yeah, so there are probably many other problems. I might not have seen them. One that just comes to my mind actually is that, so in relation to overleaf, we have often slight problems because overleaf allows errors and just compiles the document in batch mode and compiles and produces a PDF, which is nice, while AutoTeX and also our new system will error on this, so we don't accept errors like missing files. A typical example, include graphics missing and the image data is missing. Overleaf is happy with that and shows an empty square. Archive compiling is not happy with this, so we often get problems from overleaf submissions that end up in archive and don't compile there. Yeah, that's another of the problems we have. Well, not to speak of self-inflicted pain, that is, of course, we have all these tech installations, and they sometimes have to move to new servers, and then some setup is missing, and then only afterwards we realize that fonts are missing in the produced PDFs. So there are, besides the external problems, there are a lot of internal. So I want to talk also about the future. So we have the very near future, so this is like imminent changes. We are currently completely restructuring archive. In the sense, everything is rewritten in Python and put into the cloud. In a sense, we Dockerize all our systems. For the tech backend part, we have decided that we develop a text to PDF conversion system in a Dockerized container, which is a web API application based on Python. And we will ship this, still the old text systems, but we will just Dockerize them together with AutoTeX because we don't want to change anything that works for old system. But everything new will be based on this Python API web application. And we will also have auto-dispatch to the respective year when a submission was made. So you have to think about, you want to compile as an article, maybe in 10 years, we want to compile an article from 2024. We most probably will not be able to use the most recent LaTeX or TeX Live because packages changes, packages disappear, APIs for package loading changes. So we have to keep old tech lives to compile them, and this will be done by auto-dispatching to tech live containers. Also, what we get by leaving Autotech behind is, as I mentioned before, there's a lot of magic going on. So we often have to check the source code on what is going on and why. This hopefully goes away, less magic, clearer code paths. Also to make it clear, the author will have to decide which is the main file so that lots of errors go away. One thing that I'm happy about and I'm pushing a lot for is reproducible builds. So meaning that we can test changes to our system by compiling documents before and after and making bitwise comparison between the PDFs. Take Live, so the engines have included facilities for this. It's a source data epoch already, I don't know, 10 years ago. And so I have made this also a part of the new system that we can test changes easily. Another thing is better watermarking. I recently implemented it to switch to MuPDF, which is a nice library that wraps MuPDF into a Python library and works more stable and for watermarking. Also, the composition of multiple PDFs has been improved. Before, we used JPDF, but assembling the PDFs there often also loses the annotations, and then links again are lost. Nowadays, we use GhostScript. GhostScript just with PDF write device works nicely because it copies over all the objects and annotations in the PDF file, and so by this also preserves hyperlinks. And also on top of all this, what I mentioned before is that we distributed additional class and styles for long years. This will also go away. We will just say whatever is in Tech Live, this you can use. Everything else you have to include in your submission. That makes it easier for a user to know what is necessary, and it's also easier for us to maintain, and it's also more stable because there are version differences also between class files of publishers, and we only keep, if the name is the same, we only have one, the most recent version, and some submissions might need an older version, so in total this should help stability also. And the hopefully near future, so means it's something we are working on. As I said, we are working on the transition, but the main object of all this is to make it the submission process for our authors easy and painless. We really want that an author with a normal submission, in the sense normal, like it's just maybe a few text files, one of those text files is a top-level text file containing a document class, a few images, supporting material, just uploads, click one on check, and click on submit, and everything is off. So that is our idea. It should be easy. At the same time also, it should be possible for users to influence the process if they have multiple text files, if they have additional files they want to attach to the final PDF. So all this should be possible while keeping 99% or 95% of the submission very easy and quick. So this is the overall aim. At the same time also, we want to get support for LuaTech and Xitech. As I said, this is already top of the list together with the support for bibliographies and indices. And in generally, I mentioned already that we developed a web application, web API on Python that does the text to PDF translation. So this will be generally available as open source in the hope that other systems might use this. In total, we also think about, we hope in the future that we can provide the whole system as a package to other archives, to other preprint server systems, to make it easier for them to set up a new preprint service for a specific category, also research area, which we haven't covered. So this will be published. Okay, so I'm coming to the end. First of all, I want to give big thanks to all the developers of the tools that flow into TechLive. There are a lot of tools. I mean, I often compile TechLive myself, and you know, at the end there comes this 456 or something binaries made. That shows there is a lot of work going on, and yeah, so a big thanks for all the developers keeping this alive. Then, of course, thanks to the developers of TechLive itself. And I also want to thank here the Island of Tech team. They provided Docker images of TechLive on a daily basis. This works very nicely. We used them for some time. We stopped using them directly and just use their Docker image to copy the TechLive installation out of various reasons. But I think they're doing a great job, and we use their images. So thanks a lot. If you have any questions, I'm here now online for question and answer. And at any time, you can also contact me at my email at norbert@archive.org. Thanks a lot.
Okay, so if anybody has any questions, please raise your hands and I will give you the microphone.
Hi. This is Jeff Kwan, if that matters. Maybe this is something I should email you about, but this question is about LuaTech. So when I try to make accessible PDFs, I can't compile it on archive. So I've been linking to my website from the comment section, and archive moderators have let me do that, but I just wanted to check if that was actually okay due to the concern of me changing my website after the upload.
I'm not sure if you hear me.
Yes,
Okay.
we hear you. Yeah, thank you.
Okay. So thanks for the question. I'm aware accessible documents is a big question. Unfortunately, at the moment, I'm not sure what kind of accessible documents are you, at what level, let's put it. I assume PDF 1.7, UA1, which will probably not help people who need it. So we are in close contact with the LaTeX team about also working towards UA2. That is still far down the road, I would say. That is one of the reasons, and I will talk about accessible documents later on. We ship HTML documents. Concerning putting links to your homepage into the abstract or into the comments, I cannot answer this. This is a moderator decision, and I'm not on the moderator team. I don't want to preclude any decisions by them. But I can tell you that every moderator normally takes a reasonable stand about what is going on. So I assume since you got already the exception a few times that you can do this, I don't see a problem with this. Does this answer your question?
Yes, it does. Thank you.
Okay, this is question from YouTube chat I'm monitoring. The question is Autotech open source?
Yes, the Autotech is on CPAN, so you can get it there. I'm not sure how up to date the version on CPAN is with respect to what we are actually running, because we do some small tweaks now and then. I think there is no proper release management for Autotech. If there is interested, please look into on CPAN. There is Autotech. And if you have further questions or something, please feel free to contact me. And I will also look into what is on CPAN compared to what we have actually running.
I had a question about, it was about watermarking, and you've used PyMu PDF. I also had to do with some post-PDF tooling, but I always thought that it destructed my XMP metadata. does PyMu PDF preserve that metadata, or does it also destroy it?
It depends on what you do with PyMu-PDF. It should preserve them. But it's a good point. I will look into this. We after watermarking, we redo anyway the whole metadata. So we have in the pipeline that we put proper metadata both in the XML metadata stream as in the normal the old style dictionary at the end of the PDF. So I need to check whether this happens. I use PyMu-PDF actually only to add text to a page, to the first page, and then save it. So as far as my tests go, it didn't destroy the metadata. It might happen if you do some more operations with the PDF.
Thank you.
Any other questions? It seems that no, so... Oh, okay, there's another question.
I was curious which OS level packages were required for the implementation of archive. I don't know how to pronounce it.
Practically nothing. It's just a web service that kicks off a process on the background. Then are several scripts that do synchronization with databases and this kind of stuff. So I wouldn't say nothing out of the unusual. I mean, database server to have all the information in a database. Yeah, so nothing spectacular. It's practically everything handwritten Perl code.
Okay. Thank you.
So if there are no further questions, I'd like Norbert for his presentation and his answering questions. Thank you, Norbert.
Thanks, everyone.
And then we're going to switch to the next speaker, who is Mitchell Gerard. So I'd like to give the floor to him.
Good morning, everyone. Today I'm going to talk about some of the historical roots of literate programming. This is a style of programming introduced by Donald Knuth in the 1980s as he was developing TeX and Metafont. Literate programming is a way for one human to communicate to another human how a computer program works, including the motivations for writing the program, the assumptions made, the general structure of the program, and all the way down to its actual implementation in some programming language. Very roughly, a literate program looks like a big essay with a bunch of prose and some rough sketches of algorithms in something that looks like pseudocode, oftentimes formulas and figures, and some code sprinkled throughout this beautifully typeset essay. Incidentally, a literate program can be compiled into an executable that can be run on a computer, but the human-to-human communication is really the main point. I first learned of literate programming after hearing that Knuth wrote the first the first draft of TeX on pencil and paper, and then debugged it after typing this draft into the computer. I didn't believe it at first. No way. TeX was a large system, and this seemed impossible. I learned from Wikipedia that TeX was written in some language called Web, which was itself a mix of Pascal and TeX? And then that Web itself was written in, and you already know, Web. The mysteries piled up. I had to find out more. And I was soon completely enraptured with this strange paradigm called literate programming. And so the next question was, where in the world did Knuth come up with this marvelous system? As we'll see later, there was a whole host of precursors, but Knuth singled out one as a primary inspiration, the work of a Belgian computer scientist named Pierre Arnoul de Marneffe, entitled Hold-on Programming, a survey, from 1973. Excellent. I had no clue what a hold-on was, and I couldn't wait to find out. So I took the proverbial sip of coffee, fired up my search engine, and waited to be delivered this document called Hold-on Programming. But there are more things on heaven and earth, Horatio, than are served up in all your internets, and after searching longer than I'd like to admit, I found almost nothing. Every reference to this hold-on programming led back to citations by Knuth, or portions that he had mentioned in interviews. A ray of hope shone from the site literateprogramming.com, which contained 3 tantalizing paragraphs from this report, and there wasn't anything else that I could find. So I began my quest. To get a hold of this elusive report, I wrote to Professor de Marneffe, and he wrote back. He was happy I was interested in the work and would scan the entire thing and email it to me when his health got better, as he had just had a long stay in the hospital. After some time, I wrote to Knuth, who also kindly responded, saying that he donated his copy to Stanford, but that it seems to have disappeared from their records. All of this, of course, only increased my desire to read de Marneffe's report. Knuth pointed me to the single library in Germany that held this report, and also sent me a letter from 1974 that he wrote to de Marneffe, which is lovely and is reproduced in the Tugboat article. And so, some time passed, but at long last, with the help of librarians in Hanover, Germany, and Lincoln, Nebraska, I was finally able to hold all 135 pages of hold-on programming in my trembling hands. But first, let's back up a little bit and talk about the lead up to this elusive report and eventually its contents. To do so, we'll focus on 5 characters: Arthur Koestler, Herbert Simon, Edsger Dijkstra, Don Knuth, and the man of the hour, Pierre Arnoul de Marneffe. We begin our historical investigation by looking at this funny word, hold-on. Where did it come from? What does it mean? The word hold-on first appears in 1967 in Arthur Koestler's book, The Ghost in the Machine. Koestler was a Hungarian author and journalist who wrote many works, most of which were in English. The Ghost in the Machine begins with Koestler vigorously denouncing behaviorist psychologists who claimed that all animal behavior, including human language and consciousness, could be explained by simple chains of stimuli and responses. These are called stimulus-response chains, or SR chains for short, and they can be depicted like this. A simple example including one stimulus and one response would be someone first touching a hot stove and then responding by quickly pulling their hand away. But when it came to modeling human thought processes and other complex biological systems, Koestler said, "Are you kidding me? This chain depiction is laughably inadequate." Instead of a chain, Koestler says that biological systems are hierarchically ordered and are better represented by an inverted tree, branching downward, like this. Koestler uses this tree to discuss how an imagined lecturer might prepare an upcoming speech by starting with a vague idea up at the top level, or the root of the tree, and then, and here I'm quoting Koestler, at each node or branching point of the growing tree, more details are filled in. And Koestler continues, saying there is a, quote, stepwise elaboration, articulation, concretization of originally inarticulate, generalized intents, end quote. Now, if this upside-down tree and talk of nodes and branch points and stepwise elaboration seems awfully like computer science lingo, that's because Kessler took it all from Herbert A. Simon, a polymath who made fundamental contributions to computer science, theorizing about complex systems, programming languages, artificial intelligence, and general methods for problem solving. One of Simon's ideas that's relevant to our discussion is his computer program from 1957 called the General Problem Solver. Remember this phrase. This was co-authored with Newell and Shaw. So Simon, just like Kessler, talks about problems being solved by breaking a big task into a bunch of related subtasks, and if you are able to complete the subtasks, then the problem will be solved. We won't spend much more time on Simon, but I just want to note that his language and metaphors were used heavily in Kessler's development of the holon. So as a basic example, let's look at a nice, boring task, getting a drink of water. This task could be broken up into the subtasks of finding a water source, finding a cup, filling the cup, and then drinking from the cup. And these can be further broken down into smaller subtasks if we wanted. Each of these subtasks can be considered as its own separate problem, but they can also be viewed as embedded within the overall context of our initial goal of getting some water. So when Kessler introduces the word holon in chapter 3, he's citing Simon left and right, and this new word is already intimately associated with computers. Let's look at his definition of holon. It seems preferable to coin a new term to designate these nodes on the hierarchic tree, which behave partly as wholes or wholly as parts, according to the way you look at them. The term I would propose is holon, from the Greek holos, meaning whole, with the suffix on, which, as in proton or neutron, suggests a particle or a part. The main point is that each holon, or node, can be understood all by itself as a mostly self-contained unit, or it can be considered as a part of a bigger picture, depending on the desired level of abstraction at any given time. Okay, that's all for Kessler, who is the most cited author in de Marneffe's report. Now I'm going to drink some water. No cup. The second most cited author is Edgar Dijkstra. Dijkstra was a Dutch computer scientist who made seminal contributions in algorithms, program correctness, programming paradigms, etc., etc. Dijkstra is a giant in the field. A few years after Kessler published The Ghost in the Machine, Dijkstra circulated a report entitled Notes on Structured Programming. Its impact in the programming community was massive. Dijkstra said that humans are pretty dull creatures with a woefully short memory, so if we ever hope to make a computer program do what we intend, we need a bunch of guardrails and structures to help our tiny little brains out. Some of these guardrails include the systematic use of just a few now familiar control structures, including if-else statements and while loops. But today we're interested in Dijkstra's approach to developing programs, which he calls stepwise program composition. He says, quote, "The basic pattern of my approach will be to compose the program in minute steps, deciding each time as little as possible. As the program analysis proceeds, so does the further refinement of my program." End quote. Dijkstra gives each of these steps an abstract name and encourages us to use the name on account of what it does, while disregarding for the moment the details of how it works. He calls this kind of program a layered hierarchy of machines, corresponding to different levels of abstraction. He goes on to say that, quote, "Each program layer is to be understood all by itself," end quote. Let's see an example. Dijkstra wants to write a program to print the first 1,000 prime numbers. So that's the first layer. To do that, we decompose this high-level task into two subtasks. Fill a table with the first 1,000 prime numbers, and then print this table. And he goes on decomposing the problem into smaller and smaller subtasks. Both Dijkstra's language and approach are quite similar to Kessler's problem-solving tree of holons. Incidentally, this prime number program is also the problem Knuth uses in his 1984 literate programming paper. When we get to section 13 in Dijkstra's notes, which describes his second example of stepwise program composition, he does something incredible. He gets tantalizingly close to literate programming, designing a program with loads of prose, interspersed with small computation chunks that are given short English descriptors, whose code could be extracted to form an algol-like program. But then, Dijkstra turns away from his handiwork, indifferent, paring his fingernails, saying, quote, "Whatever I shall develop, it will not be a general problem solver." Note the Herbert Simon reference here. Not a mechanical one, not even one written for the benefit of the human, for the human solver, end quote. And indeed, like Moses, Dijkstra doesn't cross the River Jordan, but eyes it from afar, eventually ceasing to program entirely in his later decades. But I'm not disparaging this path. I suppose it's somewhat like the Zen swordsmanship tradition of winning without a sword. I should note that Dijkstra would loathe my connecting him just now with not one, but two religious references, but I couldn't help myself. To describe his hierarchy of machines, Dijkstra uses the metaphor of a necklace strung from individual pearls. This is not a useful metaphor. Unlike Dijkstra's Russian doll-like machines within machines, pearls do not contain other pearls. Secondly, one thinks of connecting a necklace back onto itself, into a circle. And certainly not all programs are a continuous loop. And finally, just now, one thinks of the stimulus response chains that Kessler found so unhelpful in describing complex systems. So, what is a better metaphor? De Marneffe said, but of course, it's the holon. And let us turn now to de Marneffe's report. De Marneffe was correcting more than just a clumsy metaphor. His main critique of how he saw structured programming being used comes in the first chapter of his report. Quote, "The programmer cannot use the same language for the design and the implementation of a program. When all the levels are defined, the programmer must undertake the mapping of the designed program into an executable one, a non-trivial and an error-prone operation." End quote. Another critique was that there is no suitable tool for implementing each new semantic level. Meaning, once a programmer has decomposed a program into tiny subproblems, they will not want to stuff each subproblem into a procedure because of efficiency concerns with procedure overhead. This led to programmers structuring each level in huge steps, and this takes away the whole power of Dijkstra's stepwise refinement. Okay, I've been rambling for way too long now. As Knuth suggests in his letter to de Marneffe, a holon program is mostly self-explanatory, so just show an example right away. The example program in de Marneffe's report is a solution to a problem Dijkstra poses in section 16 of his notes. The problem is essentially to take a sentence, reverse every other word, and remove extra spaces. But the details aren't really relevant here. So, without further ado, this is what a portion of a holon program looks like. Each of these three units is a separate holon. A holon is named by giving it a unique prose descriptor of the subtask to be done. For example, the third holon here is named read first symbol. The holons can be written in any order, though in de Marneffe's example, it's purely top-down, meaning he starts with the most general task and proceeds methodically to flesh out each successive subtask. Within the holons, the bold words are algol-like keywords describing control and block structures, such as loops and declarations. And low-level algol statements are bracketed between pound symbols, as shown in the third holon's assignment statement, LRS gets RNC. The ETC keyword in the second holon abbreviates unambiguous prefixes so that you don't have to write out the entire phrase, find first word starting character, every time it appears in the source of your program. I'm still struck by how pleasant de Marneffe's program is to read. It's just like pseudocode. See how digestible each little holon is? It's a wonderful demonstration of Dijkstra's stepwise program composition. And the real kicker is, de Marneffe describes a synthesizer akin to Webb's Tangle program that will expand each of these holons, just like a macro, so that the final product is a well-formed algol program, pictured on the right. You get beautiful documentation and can make an executable from a single source file. This insight of de Marneffe's is just brilliant. Now for comparison, let's look at what the equivalent fragments would look like in Knuth's web language. I know this is too much text to absorb at once, but I just want to point out that apart from the different mechanisms used to declare global variables in web and the cross-referencing aids given by web, the two languages look strikingly similar. Let's look at the second holon, corresponding to web's section number 2. Knuth surrounds his section names with brackets and uses cross-referencing, but otherwise, these two are twins. It's not shown here, but de Marneffe also describes the change command, which works almost the same as the change file mechanism in web. There's a text keyword that can act like the prose sections in web. There's the synthesize command I mentioned that acts like tangle, and there's an output command that acts like a primitive weave. But that's a bit of a stretch because there was no automatic typesetting in these early days. One of my favorite oddities in de Marneffe's report is the suggestion that with his system, programs can be written largely with ideograms, that is, small pictures symbolizing some concept. He takes this idea from way back, from Charles Babbage in the 1800s. And in fact, there now are esoteric programming languages that do just that, namely one called emoji, where you write a program almost entirely with a fixed set of emojis. Other parts of de Marneffe's report discuss an early form of contract-based programming akin to the Eiffel programming language, and de Marneffe even outlines a full-blown operating system based around the holon concept. But I'm getting off track. So what exactly did Knuth add to all of this spade work done by de Marneffe? Well, it turns out Knuth added quite a lot. First of all, Knuth actually coded up the first literate programming implementation. De Marneffe planned on doing so with HPL, or the holon programming language, but as far as I know, this never happened. Not only did Knuth develop a working literate programming framework in web, but he used it to create the first proofs that this approach actually works, and works really well, namely the programs for TeX and Metafont. Secondly, Knuth made the essential design decision to bring the prose to the forefront and to regard the program as an essay with interspersed code. The value of informal explanations, explaining design decisions not taken, adding metaphors, giving motivating examples. If you want someone else to understand a large program, these things are absolutely crucial. What else? Well, the list is long and time is short, so I'll just give a quick enumeration. Knuth typesets the code and doesn't hide it between ugly pound symbol delimiters. He adds cross-referencing, tables of contents, indices, mini-indices, appendices, bibliographies, figures, etc., etc. He brought all wonderful devices from the ancient art of literature and bookmaking to bear on composing an intelligible computer program. I want to pause to point out that influence can be a very slippery thing. I've been making the case that Simon influenced Kessler, and both Kessler and Dijkstra influenced de Marneffe, and that de Marneffe then influenced Knuth. And this is true to a certain extent. But as Bob Dylan says, reality has always had too many heads. And it turns out that Knuth, too, was an influence on de Marneffe. Knuth had been thinking about combining excellent documentation with source code long before he received de Marneffe's report. In a paper from 1963, Computer-Drawn Flowcharts, Knuth opens with the sentence, "Perhaps the greatest problem in computing today, although little has been written about it, is the need for better documentation." He goes on to describe a system to write programs that include 3 levels of documentation: a formal language, a flow outline, and a flow chart, in increasing order of abstraction and generality, that provides efficient person-to-person communication of algorithms. This system has automatically generated complete cross-referencing, like in web. Knuth also writes in this paper that, quote, "Each section usually begins with a description of its general function and some of the assumptions made. At the close of each section, another explanatory paragraph often appears, in order to clarify the more important coding details," end quote. And like de Marneffe, Knuth wrote his own response to Dijkstra's notes, in which he composes a program out of small code sections, not exceeding 8 lines, each labeled with a natural language descriptor, constructed in the order in which decisions were made, and systematically expanded and interleaved into a machine-readable form. De Marneffe cites this very example from Knuth in his Holon programming report. This is all to say, any neat and proper idea of influence seems in the end to be a happily tangled mess. There are so many other names to mention that were important precursors to Knuth's literate programming, many of which are listed in the Tugboat article. I especially want to point out the work of Peter Nauer and highly recommend his paper, Formalization in Program Development, from 1982, where he stresses how informal explanations are crucial to help others comprehend a large program. It calls to mind a Blaise Pascal aphorism that all of our reasoning reduces itself to a yielding to feeling. And one more Peter Nauer plug. His typesetting work for Algol programs, done in collaboration with executive editor for ACM, Myrtle Kellington, was huge in letting us see how beautiful source code listings could be. I'm excited to say that thanks to Carl Berry and Barbara Beaton, many of these precursors will soon be published through TUG in a slim anthology entitled Pre-Literate Programming. It's going to be a fun historical romp. One last thing. De Marneffe's entire report is now typeset, and it's freely available at this address. So please check it out. Thanks Don and Carl for encouraging me in this project, and thanks to you all for listening to me yammer on this morning.
Thanks, Mike. Are there any questions? None?
So not really a question, but a comment. Dijkstra was a very interesting character. He left the Netherlands, I think, in the early 70s and moved to the University of Texas. Sorry, the College Station campus of Texas A&M University, where he remained the rest of his life. And he wrote a lot. Everywhere he went, he wrote a report on his trips. And all of his writing was done with a fountain pen, including his software. And that software was almost never put into a computer. He was so confident it was correct. If you search for Dijkstra BibNet, you can find a complete bibliography of his works online with everything he wrote has been collected by the university and put into an archive. So it's all freely available, and it's very interesting to read.
Great, thank you. I will definitely check that out.
Any other questions? Yes?
Thank you for your talk. It was really fascinating, and I'm going to look to Holland programming report. Most of your examples were about imperative programming style of coding, including Knuth and the like. And it's kind of better, or how to say, the declarative way of stating the states of the program or stating the reality that is modeled by program is kind of better or better understandable. So I wonder whether in your studies weren't some notions of this approach of describing things that might be automatically derived into working programs. So that's...
Yeah, so yeah, in my, the old documents I've looked at have described a purely imperative style. Personally, when I have programmed with functional languages, not something like Prolog, but something like Haskell, and it is a very inalliterate style, and it's a very different approach than kind of diving very deep into very nested structures like you would do in C Web or Web. So I don't have a good response about how one would use de Marneff's and Knuth's approach in a better way in a functional language, purely functional language like Haskell. But I do know that Knuth has somewhat recently said that out of the hundreds of programs that he writes each year, maybe 4 or 5 could be improved by not being written in an imperative style. So I don't know how he would respond to this. But.
Thank you.
Thanks. This is a response to your response and to your question. I think that the need for literate programming is tightly bound to the level of abstraction of the programming language you use, but also to the level of expressiveness it has. And you're completely correct in saying that functional programming or object-oriented programming, for instance, bring new levels of expressiveness in the language, and I think it reduces the need for literate programming, because literate programming is a way of organizing your thought around the complexity of something which is not directly expressible in imperative languages. And so if you had programming paradigms in your way of writing your programs, your thought is more directly expressed in the language itself. And I think it behaves exactly like design patterns for object orientation. The need for design patterns is not because the application domain is complicated. It's only because the object-oriented language that you use is unable to express it as directly as you would like it to be. So it appears that when you use different kinds of object orientation, such as prototype programming or more extensive object orientation in dynamic languages, the need for design pattern completely disappears because the design patterns are embedded in the language itself. And so my conviction is that the need for literate programming is more embedded into a lack of expressivity in imperative programming style than other more modern way of writing programs.
Thanks.
So, Mike, I think we're done with the questions now. Thank you very much. And we move on to the next speaker. Who is Vincent Goulet?
Well, okay. Hi, everyone. It's my first presence at a TUG meeting, so I'm probably in equal parts excited to be here, humbled and slightly intimidated also to present in front of all of you, especially those of you whose software I've been using for many years now. So I guess I would like first to acknowledge my thanks to all of you who've been doing all this work. So I can see now why I was scheduled immediately after Mitch, since it will be a second talk in a row on literate programming, only from a quite different perspective. I mean, thanks to Mitch for his historical perspective on it, although I'll touch it slightly. Actually, my talk is more of a sort of a trick. I think it is clever, but maybe it's just obvious for some of you, so I really don't know. But it's proven pretty useful for me for quite a number of years now. So that's what I'd like to present this morning. I'm a professor of actuarial science at Université Laval, that's in Quebec City, Canada. It will play a role in the sense that the examples that I will present are in a context of a teacher that is preparing material for his students. Okay, so it may not apply to you, but perhaps you can transfer the idea if it can be any useful to you. So the title of the talk is actually a wordplay on the famous poem by Jean de La Fontaine, The Caterpillar and the Ant. But it really stops there. I mean, it's just a wordplay. It has no other meaning hidden in there. That what is the caterpillar? What is the ant? Is it weaving, tangling, whatever? It's just the wordplay. If we take the French version or a word-to-word translation, it's much closer to the title of the talk than the version that I put there. That seems to be sort of the sanctioned translation on the web. The software tools that have had the biggest impact on my work over the last, say, 25 years or so are the following. First is the R programming language. So I'm more of a, actual science is closer to statistics than anything else. And when I started working with R, that's quite a number of years ago. I'm proud to say that I started using R when the version number still started with a 0. It was the first language that I was using that had embedded statistical procedures in the language. Before that, I was programming in APL, where you had to program the mean function by yourself. Second, eventually I ended up using version control. Again, might be quite obvious for many of you, especially the gentleman there who has the t-shirt with a Git joke. And eventually I also learned about literate programming when the Sweave system to do literate programming with R appeared. And I so much like these tools that I actually teach it to my students, each and every one of them, because I find them important. So we teach R as the first programming language to our students in actual science, and within that course I teach them immediately to start using programming using Git, and eventually we come to literate programming, especially using R Markdown. So yeah. So of course, literate programming, as Mitch mentioned, was pioneered by Don Knuth. This is the quite famous quote from the start of his article. Mitch mentioned 1984, I think it's 1982, but he may be better than me on historic things. Yeah. I won't go into much more details on this since we had a very interesting talk on the subject already just before that. So let's set the stage for my presentation of my little trick. So the players are, well, first, if we look at literate programming in a nutshell, so the idea, as Mitch mentioned, is to combine documentation and a program in one single file and to create either the documentation or extract the code. I wrote here extract the documentation. It's really create the documentation, because usually a part of the documentation can be created from the code itself. So the weave procedure is there to create the documentation, and we have a tangle procedure to extract the source code. Now, for many years, I was wondering, I was thinking that weave and tangle should be opposite terms of one another, and I couldn't wrap my head around, just by reading the translation. I'm French speaking, so I was trying to understand. I mean, these two words seem to mean essentially the same thing, weaving, tangling. They're very, very close, and certainly not opposites. And it's just a couple of weeks ago when I actually read the Knut paper that I discovered why he called that procedure tangling. It's just that the source code that was created by his web system was all tangled together, and it was not that much readable, the tangle code. So that's why he called it tangle. So it's not at all the opposite of weaving. So there were many literate programming systems that were developed over the years. Of course, the original web system by Knut, is C implementation a few years later. This system, web, was quite more evolved in a certain way than the systems that followed, because the web system used it was not just documentation and code, but the way the code was written was interpreted by the system, something that we don't necessarily see in the other systems that followed. Of course, we have the doc system that is still very much in use to write documentation for packages and classes. No web, that will play an important role in the sequel. I'm just naming a few ones, of course. If you invented one and you're not cited here, don't be mad at me. The Sweave system that was important to me, was introduced the idea of literate programming with R. And eventually it moved into KNITR, which is another system that I know Boris is familiar with. So here's a short illustration of what a literate programming system would do. Is basically, so we start with a file. Here I made a depiction with a system that is using LaTeX as the language for the documentation and R as the programming language. You can adapt this to any other combination of markup language and programming, and it's not really important in the sequel. So we have one file that contains the documentation and the programming code, and we can extract or create the documentation itself using a weave procedure that will turn here in this example our document that will what the weave procedure will do is that it will look at the code, probably execute or evaluate part of the code, and replace the code by actual documentation or material that will be suitable LaTeX code, turn this into a text document, and then that you can compile, of course, to, say, a PDF file. Or the tangle procedure, usually, I think in most systems today, will essentially just extract all the code chunks that you will have in your original file and throw the documentation away and just retain the programming code. Here, that would be our code in my example. So nowadays, literate programming plays quite an important role in science and data science in particular. I mean, literate programming is now considered a cornerstone of what we call reproducible research. So so the idea is you tell people, well, don't key in the results of your paper in the paper. Generate the results from the code immediately to the paper. So you'll avoid mistakes. If you make changes to the code, the paper will always be in sync with the actual code. So it's quite an important topic now. And it's also an important concept between the leading tools of data science. Here I'm thinking especially about what many companies call notebooks. A Jupyter notebook is just a literate programming system. We have the same thing for R Markdown and many other systems that rely on the concept of literate programming. So it's still quite an important tool. But in these tools, usually the emphasis is really put on the weave procedure. The idea is that we want to write documentation, intersperse it with code, and eventually create some more documentation from the code. But quite, not so often do we hear about the Tangle procedure. So the idea here is that eventually, when I started doing literate programming and using it, I found it very, very useful to use the standard path of basically writing a document in LaTeX. If I need to write an example of running some code, that I will just put the code in the file, run it through Weave, and generate the answer or the documentation material straight from the code and do it like that, or generate graphics from the code and so on and so forth. So for many years it was just a very convenient use case of the system. But eventually I had some slightly different needs. For example, I need to maintain documentation and code together, but they're sort of independent in a way, in the sense that I don't need the code to generate the documentation. Okay, so the documentation can hold all on itself, but I have code. Of course, they're related, but the code is not used to generate the documentation. So there's no real need for literate programming there. But eventually, I could need to include the code inside the document. So just to typeset it inside the document, the code is not used to create a documentation, but I want to use it to show it inside the documentation. You'll see an example in a moment by what I mean there. So I was not exactly in the literate programming scenario. Also, I could have code chunks that will be evaluated in the standard weave procedure that would rely on some other part of the code, but that is saved as files on the hard disk. So I don't just want to reuse a code chunk that is somewhere else in the document, but the code chunk must be saved as a file before. But I want to maintain everything together, but it has to be in a separate file, but I want everything to be in the same file. So I had to find some other way to do this. And I wanted a self-contained solution, something that would be done in just one step. And self-contained meaning that I try to remain only inside the system of weaving and tangling. Of course, you could say, well, just do it using some external tool like Make. Of course, you can do everything you want and plan all these things using Make. I was trying to do it without using an external tool like Make. Okay, so here are a couple of examples. So I'm still not showing the trick. I'm still just showing you what I was trying to achieve. So I have one document, one textbook that I wrote for my students on programming with R. And so basically I have the text of the manual, of course. And I have sample R code that is included at the end of every chapter. Okay? of course, it is distributed separately as just script files, but I wanted the document itself, the PDF document, to also contain the R code. So this sample code is included in the manual, but it's not otherwise used to create the manual itself. It's just sample code. So originally, what I would do is to maintain all the files separately. So I would have the TEC files that would contain the text of the manual, and I would have the sample code separately in .r files. So it proved a little bit, it worked perfectly well, but it proved a little bit cumbersome to synchronize the two documents. If I would make a change in the manual, I would need to remember to open the R file and do the adjustments there also. And first and foremost, I would obviously compile the document and check, well, okay, everything is correct in the document, but I would not so often think of checking whether my R code was correct by just evaluating it. So, and actually there were tons of mistakes in these R files because I would just not think of checking them. And remember, I said, no, you cannot argue, well, you should have done it with make and make sure that everything is always checked. I was just not using it. So eventually I came up with a system where I can maintain everything in .rnw files, so literate programming files. So many files because I have one file per chapter, okay? But every file for one chapter contains the code for the documentation and the sample code also. So I have obviously fewer files to maintain. But what I eventually could come up with is the fact that I could split the sample code by section. Instead of having one large file of sample code, I could just write, if there was sample code for one section of a chapter, I could just put the sample code for this section after the section, start writing another section, then the sample code, and so on and so forth, instead of maintaining the sample code in one large file. And what this system provided me with is the fact that each and every time that I compile the document, the source code is actually evaluated and checked. So if there's a mistake in the sample code, the compilation will stop. Okay? One caveat there was that these files of sample code that are included inside the typeset document need to exist, because somewhere in my TEC code I have an include listing something to include these files to appear in the document. So I needed to have the files present on the disk to be included back in the document. So basically we need to extract the material from the source, create the sample code, and then include back these files inside the typeset document. Here's one other example, slightly more complicated or involved. I have a term project that I'm distributing to my students and a lot of material to maintain. So obviously the text of the assignment itself, okay? So that's the documentation part. But I have a lot of other material to maintain. The solutions to the term project that I want to give to my TAs or to myself. I distribute unit tests to the students so that they can test their own functions on tests that I design myself, so that they can check whether their functions are correct. So I give some unit tests to the students, but I have other tests that are used for grading purposes that I need to give to my TAs. Also, to do the grading, we need some shell scripts. And on top of that, we have some configuration files, just very, very simple text files that are used for a grading system that I designed. So a lot of material that I have to maintain. Originally, it would all be in separate files, perhaps in one subdirectory of the directory for my course. With the system that I've been using for a number of years now, I can maintain everything in one single file. I say huge file. I mean, let's just tone down the scale here. The file is not that huge, but it's huge in comparison to the number, to the length of the material to create the actual document that the students see. Actually, I have about 900 lines, so about 6 or 7 pages for the material that is distributed to the students, but I have 3 times as more lines of code for everything else. That's all in one file. So I have a very close proximity between the questions that I ask to the students and the solutions, because in my document I can write, well, do this type of function that will do this and that, and write the solution immediately underneath it. Obviously, the students don't see the solution. But I can maintain everything in very, very close proximity instead of keeping that in separate files. It's much better this way. It's much easier to maintain. And one other very, very nice thing is that the unit tests that I give to the students, that I give to the graders, they're all executed also when I compile the document. So in other words, I'm sort of auto-validating my own code each and every time. The only thing I have to be careful about is to write a question that matches the solution. Because the solution, it works, it passes all the unit tests. So the really crucial point here is to ask the correct question, basically. Okay? So each and every time that I compile a document, I'm quite confident that I have material that is consistent, that it works together. Again, in the unit test, we have to import the solutions. Okay, all the unit tests work this way, by reading in the code, so the files have to exist again on the disk before we can run the unit tests. So the unit tests cannot rely on a code chunk that is somewhere in the document, because the unit tests are written in a way that they should read an external file. So what's the trick? Well, we have a weave procedure that in the R terminology is called sweave. Why not R weave? Because it was designed at a time that R was still seen as the GNU version of the S system. But the S system no longer exists, actually. It's one of a very, very rare case of an open source software that virtually killed the commercial counterpart. So, they used S as a prefix for historical reasons. So we have a sweave procedure that evaluates all the code in a .rnw file. And we have S-tangle, or the tangle procedure, that extracts all the code from a .rnw file. And I need to do both, actually. I need to sweave and stangle in the correct order. So the trick, basically, is just to combine the two by using the tangle procedure inside the weave procedure. So when I weave the document, I first tangle it. So that I can create the source files on the disk and then reuse them after a while. So that's the trick, basically. Remember this diagram that I showed earlier? So where we had sort of very separate paths between weave and tangle. Well, what I basically do with my little trick is to go this way through the diagram, is to always start by weaving, but at the beginning of the weaving procedure, We first tangle, finish the tangling step. Once tangling is done, we complete the weaving step, and then we end up with the PDF document at the end. Here's an example of how it works. So, very simple document. Here, the notation is that we have these symbols to activate a code chunk. This is no web syntax, and the @ sign returns to documentation mode. And if we don't put any equal sign after the brackets, it just means include another code chunk. Inside a code chunk, you can use a code chunk that was defined previously. We'll see that on the next slide. So here's the idea here. The very first code chunk in my document actually calls the tangle procedure. So the first thing that gets source name is just a way an internal function that I wrote to sort of retrieve the name of the file that we're actually compiling. This, we'll come back to this in a moment. But you see that the first step, the first code chunk that is evaluated in the document is actually to start tangling the document first. So here we have another section. This is just a regular weaving procedure where we can define, this is a solution basically, where I define the code of the solution, and since the code chunk is named, it will create on the tangle step, it will create a file called importstations.r. So at the tangling step, the file will be created. On the weaving step, the code will be evaluated, and a function will be available for the following code chunks. So that, for example, later in the document, I can use the function and show usage of the function. This will be created by the weave procedure naturally, just like the usual way we use literate programming in data science. Now, if we look at the unit tests now, let's just assume that I mentioned in the previous slide that a file called importstation.r would be created. Let's just imagine here or assume that another file called revenues.r will be created also on tangling. So now tangling is done. My files are created on the disk, and weaving of the document continues. And eventually, we end up on the following code chunks. Well, these code chunks, what are they doing? They're the unit tests that on tangling will be created as .r files that will be distributed to students. But now we are weaving the document. So the code is executed. And these unit tests, what they do is they import, they have to source the R files. These files now exist because they've been tangled before. So we can reread the file, execute all our unit tests on the weave procedure because I tangled first. And then I'm weaving, and now I can rely on the material that's been tangled. And here, just for the sake of it, just to show a little example of what we can do, is that these code chunks, they're actually not tangled because I don't want to have separate files for each and every test. I want one big file for all the unit tests. So basically what I distribute to students is one large file containing all the unit tests. So how is this file created? Well, by just creating one large file at the end, one last code chunk, that will import all the other code chunks and create one large file. These code chunks will be evaluated at the weave procedure, but not the later one, because we don't want to execute the unit test twice. We just want to evaluate them once. So here actually, so this is basically how I can manage to maintain all the material in one large file. I think it's, if not clever, certainly useful as a way to maintain documentation and the rest of the code. Here, ignore on tangle, ignore on tangle, and ignore on weave are not standard keywords that are supported by Sweave. So I might just say a couple of words on just a small R package. I mean, maybe very few, if none of you are actually working with R, so I'll be very, very short on that. But the idea here is that I just wrote a very small R package that provides additional Sweave drivers with, as I wrote here, extra tricks up their sleeve. So the idea is that when we say ignore on weave, it means that when we are weaving a document, we can just completely skip the code chunk. So what it allows me to do is to maintain code inside a Sweave document that is in other languages than R, that would otherwise not be, that it would not work on the, or that would stop the weave procedure otherwise. Ignore untangle can ignore a code chunk on tangling, yet weave it as is. So it's just a way to avoid cluttering on the file system to create, otherwise tangling will create one file per code chunk. And there are some code chunks that I know I don't want to be saved as files. So I can just say, well, ignore this one, don't tangle it, I don't need it. And eventually I added another option that's called the extension. So when I have code chunks that are in other languages than R, tangling will always extract them to file with a .r extension. And sometimes it's just text file, for example, because I maintain the README file inside my big document. So I could just extract it to .txt or .md, whatever, by using an extension trick there. So yeah, I guess that's it. I hope it will be useful. And I don't know if you spotted the movie references there, written there. So thanks very much for listening.
Probably expected this question. Did you try to port this package to knitr as well, your R Sweave extra, to make something like R knitr extra package?
To port it to knitr?
To knitr package.
Yeah. So for the record, knitr is another system built after Sweave. Originally, knitr was a system that added a lot of options to Sweave. Personally, I always thought it was just too much. Well, Sweave was lean and mean, and I always stuck to that system. Eventually, knitr became the basis for R Markdown, which is another literate programming system where the base is not LaTeX text or LaTeX markup, but instead Markdown markup. That's what I teach to students because it's easier for them. But I also tell them, and I'll come to your question in a moment, I also tell them, well, our Markdown, or Markdown in general, it's very, very good to do simple things. But it's very complicated to do complicated things. I mean, simple software are useful to do simple things. And especially for students who need to write mathematics, quite often they eventually need to know LaTeX. So I usually tell them, well, just learn LaTeX in the first place and you'll be done with it. I'm not a user of Markdown. I always stayed on the LaTeX side and Sweave, so no, I did not really look into porting it or doing it, making it compatible with NIDAR.
Any more questions before we go to coffee? Yes, Nelson.
One of my many activities is maintaining Unix.bib, which records articles about Unix and its history. And one of the things we've tried to do on the Unix Heritage Society mailing list is dredge up copies of a lot of old documents. And as you observed, and also the previous speaker, sometimes these have disappeared completely. Mm-hmm. And I raised the question a couple of months ago about the sources for the S language, the original statistics language from Bell Labs. And got only a couple of responses, and then someone said, well, you know, John Chambers, the architect of S, is still alive and working at Stanford. Why don't you ask him? So I did. And he confirmed, as far as he knows, those sources are gone forever. Wow. They're documented in a book, but nobody seems to have copies anywhere. It's possible it will still turn up somewhere on some tape that somebody uncovers. One list member reported that he recalls building it from source code, and it was a mass of Fortran and C, and quite complicated to deal with. But it is well documented in the original blue book that Chambers wrote with another author. But unfortunately, there are a fair number of instances in computer science, or probably the youngest scientific field, where the original materials are gone, and we can't get them back. And it's very, very sad. It should never have happened.
Yeah. Thank you.
So with that, I think we need a cup of coffee. So there's a break now for half an hour. I'll see you back at past.
back and forth stuff. And this is probably what I need.
I'm going to give an announcement on the photo after lunch.
Yep.
And just take 30 seconds here before we start up, so people don't linger at lunch.
They will anyway.
Someone else's job is to go around.
Meeting at lunch is an important part of the conference.
Yeah. Right, I think pretty everybody is back now. But before we start with the next talk, I'd like to give the floor to Alan with an announcement.
The most important part of the conference will be happening right after lunch, the group photo. Without the group photo, the tugboat issue will look empty. It's scheduled for 1:15, so you do not have a full hour to linger at lunch. At 1:15, we're going to meet on the stairs after lunch. I'll take the quick photo, then you can go back and finish your discussions. But please do not be late. We'd like to have a photo. Thanks.
Thank you, Alan. So please remember that. Now we continue the program with Martin Ruckert. So Martin, please.
Thank you. Thank you. I'm Martin Ruckert from Munich University of Applied Sciences, and I talk about profiling tech input files. So let's see how that works. Okay, that's what we do. Short introduction, what it is, who needs it, who doesn't need it, how it works, and then we continue with examples. Okay, a profiler maps runtime to program source lines. Here is an example where you see one line and a file and some absolute milliseconds and a count and a percentage. The other thing that it does, it maps runtime to program functions. There's also an example where you can see a swap to args macro. Macros play in tech the role of functions. And there is a total time that says how much time is spent in this macro from the beginning to the end, including all the sub-macros. And there is a breakdown of the time that is spent directly in the macro. Here it's 1 millisecond, and there are sub-macros like the 58.09 milliseconds that are spent in input file exists with hooks. And there is a loop sub-macro. We will look at that in more detail when we see the examples. Who does not need a profiler? If you just write documents with tech, you don't need a profiler. You might need a profiler if you are a macro programmer and you care about runtime and your macros are used very often. Now, what does it mean very often? Here is a short calculation. 1 second CPU time causes about 28 milligram of carbon dioxide emission. Driving 200 kilometers with your car is 28 kilogram of carbon dioxide emission. So before your time savings in computing time make any difference, you need millions of seconds. So my macros that I write for my own purpose, run quite often because tech is part of my make file, but I come a couple of thousands runs per year. So I not even get nearly to the millions Yeah? So I don't need a profiler, and most of you probably don't need a profiler either. But there are packages that have millions of users, and these millions of users run these packages on a daily basis. So you really get in an area where your code could make an impact, and that's probably when you might want to look at a profiler. Okay, the profiler will tell you where you can look for optimizations and where not to look for optimizations. That's most of the time the important part. And if you did any optimizations, it will tell you if your optimizations had any effect. And you should never optimize for speed without a profiler. So if you want to do that, now you have that tool. Okay, how does it work? We collect data. There's a special tech engine, the tech profile tech engine, and inside that engine I modified the main control procedure. The main control procedure has the big switch, and it reads one token, the getX token here, and then it executes the token, the command in that token, and it goes back to the big switch. So that's the main loop, and I modified that. I look up the time at the beginning of that loop. I take the time from the clock. Then I get the token. After I have the token, I determine the command and the file and the line and the macro for that command, and then it gets executed, and I get back to the big switch, and I look up the time. When I look up the time, I get simultaneously the start time of the interval and the end time of the last interval. So I don't lose any time, I just look once. And then I write out the data into a big array. There is, that's not the whole truth. There's also something called the main loop. It's looping over characters, current spaces, that kind of stuff that is inside plain text. So inside these main loops, I don't do that lookup time stuff. So you might associate a longer stretch of time with just the first character that starts a paragraph. This is usually not a problem because we are not really interested in timing plain text paragraphs, but nobody optimizes his paragraphs for speed. I mean, you optimize macros, but not your document. So, and usually such a paragraph is executed only once. So the time spent on a single paragraph is very small in compared to time that you spend on macros that you evaluate 1,000 times. So that's what you do, and once you have that, you write it to a file, and that file can be analyzed later on with a different program. There are some problems. The soft problems that are easy to solve is get for each command the file and line and store it. Get the name and the file and the line where you define a macro. Keep track of the macro stack, keep track of extend and backup, and there are hard problems. Hard problem is getting a reliable and consistent time source. You have time sharing and interrupts. So that means you measure time, but your program gets swapped out because another process needs your CPU, and then you get swapped in, and the next time you load some data from main memory, your CPU will check and see, oh, it's not in the cache. And then you read the data from the main memory into your first level cache, and then in your second level cache, and then in your third level cache, and that takes a lot of time. And all that time is charged on the poor command that happened to be active when you were swapped out. So this, of course, is a problem for getting consistent times. Frequency scaling. While your program is running, your CPU detects that there is a lot of work to do, and it scales the frequency from 1 gigahertz to 4 gigahertz, and all commands that come later run faster. You have performance cores and efficiency cores, and your operating system might decide while TeX is running to move TeX from a performance core to an efficiency course because it needs a performance course for something else, or it moves it back, and that changes timing. So the current accuracy is not very good, around 100 microseconds, even if the clock is in nanoseconds. So, but that's about it. We could use multiple runs. It's not yet implemented an average over multiple runs, and we could use synthetic times because we have an interpreter and we are not really interested on how long it will take on this laptop or on that laptop. We could have a virtual machine and virtual timings, and that would give us a good picture how would it run on some machine, but not implemented. Okay, now we turn to the examples. That's an interesting part. An introductory example is the sample 2E TeX document, 3 pages, very short, medium use of macros. And then I looked for a large document that is mostly TeX, and I found one. I converted it from LaTeX to plain TeX, and I show you the plain TeX version first, and then I show you the LaTeX version. And then I have the C-Web output of my profiler, TeX profiler itself. It's a modified TeX engine, which is medium, large, 700 something pages, high use of macros. And the interesting thing is, if you look at the timing, that PDF TeX is much slower suddenly than normal TeX. And we will look at that. Why is that 10 times slower? Okay, here is the first example. You probably know that file. There are macros in it, and it's all LaTeX. You run it, LaTeX prof. The TeX prof is just a TeX engine that profiles, and you give it the -prof option on the command line, and so it does the profiling. And it looks like normal TeX engine. It loads the LaTeX format and makes 3 DVI pages, and that's it. And of course, you create a new file. It's sample2e.tprof. That's the data collected. Now, this data collected, you give to a program called tprof, and tprof extracts the data and brings it into a readable form, like this as a, well, just total time measured, number of samples, average times, number of files, number of macros. All the LaTeX macros are in that file, of course, and quite interesting nesting of the stack. Here is another analysis. It's the -t option, gives you the top 10 lines, the 10 lines that used the most time. And the first line is disappointment. It says that 49% of all time is spent in an unknown file, in an unknown line. This is because the program was run by loading the format file, and in the format file, there is no information about lines and files. So, and since all of the macros in this document are LaTeX, and LaTeX is loaded from the format file, it has just no idea. And the rest, I mean, the article class is just 0.1 microseconds, so that's not worth looking at. Okay, how to get around this? We modify our sample to TeX and load LaTeX directly from the file. And we can switch profiling on and off by using 2 primitives, profile on and profile off. So that's how it looks. We redefine dump because input LaTeX will execute dump at the end, and that will terminate the program. So I redefine dump, so it's not dumping it. Then, after I've loaded LaTeX, I switch profiling on, because I don't want to profile the loading of the LaTeX format. And then comes the usual file. Now, this is how you run it. You don't run LaTeX prof, but you run TeX prof, normal ini TeX with a -ini. You enable the epsilon TeX extensions, you enable the LaTeX extension, and then you have the file. And This one is shorted. There are these dots. It creates lots of output because it creates all the format, and then it runs, and this is what you get. Okay. Total runtime is about 5 seconds on my PC, and the measured time is only 33 milliseconds. That's a bit longer than we had before. And the reason is it calls init tree because you load the hyphenation tables from source files. And so it initializes when the first time it needs the hyphenation tables on the first paragraph. It initializes the tree, and that's the 12 milliseconds that it now needs extra. And it's charged on the system. And the rest of it, what will it tell us? It will tell us that Frank can relax. There is nothing to do for him. It's the only line that has a significant percentage is line 1536 in expl 3 code tech, which is responsible for about 7%. Now, if you optimize this line, and we will see an example, how much can you gain? You might get the 7% down to 6 or 5 or 4% maximum. So what you can save on total runtime is 1 or 2%. Yeah? That's not very much. So my advice is look at that line. Yeah, I haven't done that because I don't read LaTeX code very well. Look at it. If you can do something in 1 hour's work, do it. If you need a day's work, forget it. It's not worth it. There are better ways to spend your time. Yeah? And that's what it will tell you that. Okay, so far the introductory. Next example. I looked for a large body of text, and I found the Bible on the internet. So this is the book of Numbers here, and it's over 1,000 pages, and it's mostly plain text, mostly text. Okay, this is when we run the profiler and look at the top 10 lines. And we see one line, it's line 29 in bible.tech, and it takes 18, almost 19% of the total runtime. And that's 135 milliseconds, and it's called 54,000 times. So, and that's an interesting candidate. The rest is ship out, line breaking, page building, and the rest is below 1%. So you no need to optimize anything but this line. Okay, this is the line. It's the verse macro, and you can see here it makes these small numbers at the beginning of the verses. Okay, how can we optimize that? Global is not necessary. Verse is used only on the top level. By is an optional keyword. Leave it out. It's scanned if you put it in, but if you don't put it in. 1 is scanned as a character. So if you have literal constants, they are scanned as characters and converted to an integer. Math mode, well, just to raise a tiny little number a little bit and make it smaller is overkill. So this is my new version. I defined a count register to make the advance faster. I have a new dimension register because I have to raise that box, and I have a 7 Roman verse count, and I say advance verse count by \1. Yeah? So this is the optimization I made, and yeah, avoid optional syntax if you don't need it. Use registers for constants. Use math for mathematics. Yeah? We use it often for formatting issues, not for math. Okay, before optimization and after optimizations. And we actually get 2% savings, down from 18 point something percent to 14.56%, but there is an additional line here that wasn't there before, and this is the, oh, I should go back and show you that. This is the leaf vertical mode, because you can't use raise in vertical mode. So you need that extra to switch to horizontal mode before you can use a raise. Yeah? And this is now extra, and this extra leaf vertical mode needs another 2%. So you get to 16% something instead of 18% something. That is something you can do with a modest amount of work, not more. The rest, yeah. Okay, this is it. And this is also a good example of looking at the call graph, which you can get with a profiler. When you look at lines, that is pretty low level. And if you have, well, if you would take this verse macro and spread it over 10 lines, it wouldn't have 18% in one line, it would have 2% in 10 lines. So you wouldn't see it, basically. So this is a high-level approach. You look at a certain task, like a macro, that combines several lines into one task and one purpose. So we see here the verse macro is responsible for 27% in the first line. And now the next thing is the breakdown. These 195 milliseconds are split up in 140 milliseconds that actually are used in the verse macro, and 54 milliseconds that are in the output, because often the verse macro is at the beginning of a paragraph, and then it starts the build page, and it might cause calling the output routine. And you see that here. So part of verse is just time that goes into the output routine. After switching to horizontal mode, you have the same verse macro that is now a little bit faster by 2% overall. And the time spent in the verse macro goes from 140 milliseconds to 100 milliseconds. And you spend a lot of time in the leave vertical mode. And leave vertical mode spends most of the time in output. So that is what you can see if you look at the call graph. The call graph gives you some more high-level information. Okay, then same example, going back to LaTeX, looks pretty much the same. This is the profile time. It's about a second slower. Why? Okay, there is our favorite line number 22, which is now not 18 but 8% because the whole program runs longer. Then there is one line which takes 7%, which is probably not something you want to optimize. And the rest is something that, well, is okay. Let's look at the call graph. The most expensive macro is now the output macro, and that's what you expect. You have a file that is mostly text, so not very much is going on while scanning the text, but occasionally you call the output procedure and you call it 1,192 times. That's quite often. And the output procedure is where a lot of complexity is in TEG. Most of the output routine is in the up call procedure, 97% of the time. Then comes the verse procedure already, and verse gets a little bit slower by calling every par, every math, and again every par. There are two every par procedures, one in line 7,257, it's this line, and the other one in this one. So it uses two different every par, probably, I don't know why they are different every par procedures, but they are different. The last one is only called once, and the other one is called 31,000 times. The next is the upcall macro, which then splits its time between output page and expl mark update single something. And then on fourth place, you have a procedure called useINN, which is in itself pretty fast, but it calls a lot of other procedures. I'm not sure what it does and if it can be optimized and what you might gain. But these are the procedures you might want to look at, if at all. Okay, last example. It's the TEG profiler itself. It's written as a C-web program, so you get a big TEG file that you can produce, and that's how it looks. And it's lots of macros. Here are the runtimes. If you run TEG on it, 270 milliseconds. TEG prof similar. If you switch on profiling, it gets a little bit slower because you have a certain overhead. And PDF is much slower. If you make PDF draft mode, where it doesn't generate output, it gets faster. PDF is a more complex output format than DVI, so it needs more time, no question. And high-tech, that's where I discovered it, is also about 1600 milliseconds, but it's really much slower. So how to profile that if the problem also only occurs in high-tech or PDF tech, and tech prof is neither one, you have to pretend to be high-tech. So you define all these macros that you have in high-tech, even you have the hint version, which the macros in the C-web system discover, okay, this is high-tech. It checks for that version, and then it pretends to run high-tech, and okay. Then TechProf actually profiles the program, and it needs also the 1600 milliseconds. So we have the effect. Here are the top 10 lines. And what you see is that in the C-web Acrobat macros file, line 156, 57, 58, and 59, these 4 lines have about 50% of the total runtime. That's where you want to optimize. The rest is a little bit something of everything. And if you look at these lines, it's where you process the index. The index is actually written by the C-web system, and then it's processed. And the processing for PDF tech or high tech is more complex because you have to turn the line numbers into links. Not the line number, it's the section numbers for web programs. So every section numbers has to be turned into a link, and that makes it expensive. You have these add tokens and pop tokens, and then you have make toks, which calls pop text and defines some procedure next based on the next character, and at the very end it calls next in a recursive loop, and that makes it expensive. Here you see the macros. PDF node is 95% of the total runtime. PDF tech calls make toks calls next, and next is itself pretty fast, but it's called in a loop, and you have the time spent in the loop is 1.15 seconds. That's where the extra second comes from. Okay, so there is maybe something to do. Summary, specialized tool, open source on GitHub, not perfect, but maybe useful. It will tell you where and where not to do optimizations. And if there is substantial demand, there is room for improvement. And we are at the question section, and I have some questions. Should it go into TeX Live, for instance, or is it too special? Is parsing input files necessarily slow? Do we need special TeX primitives to speed up common tasks? That's my question. And, well, thank you. And your questions, please.
Who would like?
question. LuaTech and ZTech are often very slow. Do you want to port your profiler, then it can pretend to be LuaTech or ZTech?
Yes, maybe, yeah, probably yes. I mean, I have the sources. If you say you need this and that primitive, I mean, faking this and that primitive, it can be easily added. You can make a switch on the command line saying, please pretend to be this and that, and I just look up the primitives and copy them over and say, okay, these primitives are here, and they don't do anything. That's possible. That's, if there is demand, there's improvement. Yes, please.
In tech, there are several ways to define commands. For example, def, edef, or in LaTeX, a declare robust command. And did you notice some influence about profiling?
I don't think that the definition by itself makes much of a difference because it's executed usually only once. And once the macro is defined, it's in the hash table and you just take it out and put it on the input stack. So I don't expect anything here, but use it and find out. I don't know.
Yeah, I recall that Hans Hagen talked a lot about profiling when he was developing Lua MetaTech and so on. And I don't recall the details, but I think he was working a lot on improving the context code, but that's of course a lot of code gets rewritten into Lua instead of using tech code. But I think one of the remarks he had is like, it's already, if you're dealing with Unicode, it's already slower just because you have like a lot more memory to optimize, and yeah, probably the same if you're dealing with open type fonts, it naturally gets slower. So that's a bit in response to what Boris said about LuaTech and ZTech being slower. This just happens to be a side effect of Unicode and open type.
There's a big difference between profiling an engine, where you can use the GNU profiler to profile programs and see where the time goes in the engines, or profiling tech macros. If you run the same macro on LuaTech, you will execute the same tech commands and the interpreter will do the same stuff. So I don't think that the execution time for the macro will be much different if you use LaTeX, PDF tech, or whatever tech, or LuaTech. If, of course, you move computer time from expanding macros into the engine, then it disappears. That's something else. This is a profiler just for macros. If you expand the same macro on a different machine, that should be no difference.
Last question.
Last question, you said? Well, the question really is about, again, profiling something like LuaTech, because the interesting point is not to fake that you're running on LuaTech. The interesting point is to capture the part of code that is not a macro, but a call to the Lua part of it, and get that information back. Because this is the difference between, say, LaTeX on PDF tech and LaTeX on LuaTech. Some of the code that is in macros and PDF tech, because we have to, is being replaced by Lua code. And if you don't capture that, the whole operation of telling me what is in the profiling results is useless, because I don't see the extra time going into the Lua, which may be worse. We have just now somebody who is very keen on doing this kind of change and implementing some of the Expel code directly in Lua. And it's quite interesting to see his profiling results, because some of the functions become slower in Lua under certain circumstances compared to what we do in tech macros. So if there is profiling on LuaTech, I think you really have to
get at least to the level of getting the start and the end point of this Lua code as part of the profiling?
Yeah. If you want to profile on a different engine, like LuaTech, then you have, this is open source. You can take the points where I put in the profiling code into the regular tech, and you can do that and put it into LuaTech at the same places. That might, and of course you can also time the, get a separate profile on which functions in Lua take what time and which lines call that. That is the information you can get. But you would actually then take that profiling code from my engine and move it to the LuaTech engine. Well, now that you have the code, it's probably a month's work. Yeah, okay, so.
Okay. Thank you, Martin.
Yeah.
I think time is up, so we move on to TUG Thiessen for the next talk.
All right. Today I would like to, talk about a project that I worked on for a few years as a side project. And just to start with the gist of it all, it's a re-implementation of TUG 82 in Rust. And I would like to give you just a short introduction why I even started doing that, how I proceeded working on this, some difficulties that I encountered rewriting this code, and what I have today and the outlook. But before I get to anything else, maybe just a little bit about myself. I don't really, I'm not an expert in tech. I work as a researcher in cryptography at the Technical University of Denmark. And so for me, this whole project was my first real encounter with low-level tech. So I've written, of course, as a researcher in natural sciences, I've worked with LaTeX, I've written my thesis in it, but I didn't really know how it worked on the basic level. Neither am I really an expert in Rust, so I've dabbled a little bit with the language before, but I didn't quite know it that well. So both of these are not as true anymore as they were at the start of the project. So I've learned quite a bit about both of these languages. So why I started, I recently had moved back from industry where I worked as a programmer to academia, and I was afraid I would miss the programming. So I was looking for a medium-sized programming side project, and yes, there's a little bit of naivety. I was a little bit naive about the whole process, I imagine, and I also wanted to gain some interest, some familiarity with Rust. So my first inclination was to write some sort of parser, and so I was looking at different languages. I was considering writing a PDF parser, but I heard that is very complicated, so I didn't do that. And because I was just moving back to academia, I was working with LaTeX again, and then I thought, oh, it might be fun to write a parser for LaTeX. While I was looking for a grammar or some description of it, I stumbled upon this file, tech.pdf, that you can get when you run a tech in your command line. And I found this beautifully documented code of tech itself, and I thought, oh, this is nice. I can just try to rewrite that in Rust. That might be a fun project. So my initial motivation when I started this project was how well can it even be translated to a modern programming language? So I knew, of course, of the reputation of the code that is basically almost bug-free, and so I expected that it might be nice, so it might fit well to some of the modern ideas that we have in programming languages. So in particular, I was trying to figure out whether I can rewrite it in idiomatic code. At the same time, I wanted to figure out whether it might help make the code easier to understand by utilizing more structure in the code, using stronger types and methods on data and stuff like that. And a bit naively, I also thought maybe the performance could be improved. I suppose the majority of you knows quite a bit about TEG, but just to give a very brief summary. So TEG 82 is still today the base of TEG engines and was written in this literal programming language web, which compiles essentially to Pascal. And if you study the code, you can see that it has been written with really great care to use the absolute minimal memory, which was essential to run on the computers of that day and age. At the same time, it tries its utmost to be portable. So I'm not a computer science historian, but I understand there were many more operating systems and machines at the time. So it has no external dependencies. It makes minimal assumptions on the facilities that the operating system provides. And it sticks to only a subset of Pascal. So there were different dialects of Pascal with differing facilities, maybe some string facilities, but it sticks only with that which could be reasonably assumed of most Pascal compilers. So because of these constraints, there are a few things that are a little bit different from how you might write code today. So all memory is statically allocated. There's some very large arrays that are then used basically manually as dynamic memory. There is a lot of global variables that are used for all different kinds of purposes. Constant strings in the code are handled via a pool file. So they basically each constant string is represented as an index into the pool file, so that if you have repeated strings, then you can save some memory. And dynamic strings are stored in a single buffer. And there's lots of go-to statements, which is a little bit of an issue for languages that don't provide go-to statements. So Rust is a fairly new programming language. It's quite, I suppose it's quite popular these days. It roughly, I think, so my understanding of it is that it's roughly in the same corner as C++. So it's very fast. It is, you don't pay for stuff that you don't use. So you have very much control about execution time and about memory layout. It provides a lot of type safety. So you don't really encounter bugs very easily where you accidentally convert one type to another. And a big feature nowadays is that it has a system that allows it to be memory safe. So you never, if you have a conforming program, you can never encounter a case where you access invalid memory. So with regards to how well it's suited to translate web translate web format, it is an imperative language, which is good because Pascal is imperative, and so in that sense it's easy to do. It has a macro facility, so because web uses macros quite extensively, that helps you to create the Rust code. And if you want to stay with at least with a semi-fast and maybe a controlled memory usage, it allows you to do that as well. On the downside, though, it does not allow mutable global state. So this is part of the idea of ensuring that you never access invalid memory. And that, of course, is a problem if you have lots of global variables. There is no go-to statement, and you don't. For the same reason, you also don't allow transmuting of memory. There is, though, an escape hatch, because this language is targeted at implementing low-level programs. You sometimes need to be able to do things that can be unsafe. So the idea that it works is that you label those parts of the code where you do something that could be invalid with an unsafe word, and then you just make, by manual inspection and reasoning, you make very sure that that part is correct. And in that way you can have a mixture of safe code that is guaranteed by the language to be safe and unsafe parts that are humanly assured to be safe. So, and with this escape hatch, it was possible to do a first translation. So, while I started with this project, I learned that there were other attempts of doing it, and I realized that it might be a bit tricky to do. So I decided for the following approach, which I called Ship of Theseus approach, where I start with a translation that is as close to the original as possible to avoid introducing errors that are very, very difficult to fix later. So with this initial, so I did this initial translation. Then I used the trip test. So if you don't know the trip test, it's one tag file basically that is extremely convoluted and hits all the weird corner cases. And you need to ensure that that file gets compiled exactly if you want to make sure that the tag implementation is correct. And then my hope was to make the code more idiomatic in a step-by-step fashion. So the things that I was hoping to improve within in this process was to use the actual dynamic memory that comes with the language provided. So that you don't have to have these static arrays, and that allows you to get rid of some constraints. You can easily grow the memory and adapt it to the usage of your tag files. Then to utilize the built-in data structures such as hash tables, dynamic arrays, and other things, and just use the language and the facilities that this language provides to make the code, the programming easier, and the code maybe easier to read as well. And in the same fashion to use richer types. So, for example, Rust comes with an enumeration type. So if you have a finite set of states that you can be in, you can use this enumeration type to list these states, and you can be sure that you can never have a state that is outside of the set. And at the same time, the compiler can help you to make sure, if you're trying to cover all cases, that you indeed covered all cases. I also, and this is something I did initially, I got rid of the string pool because that is actually very, very difficult, even with the initial implementation, to include. So I just started with static strings. So inevitably, there were a lot of challenges. So I wrote this the initial translation. I did it manually, and this is definitely not the best use of time. I think it would have been much, much faster just to try to write a transpiler in the C-Web style, maybe. But there's a certain zen to just implementing it, and I also wanted to get a first read of the code. So while I was implementing it, I already had an idea of the layout of the different parts, even without understanding what it was actually doing in detail. So this manual translation, of course, created some bugs because somewhere you forgot maybe a line, or had a small spelling mistake. So I worked on this manual translation then to get it to compile with a trip test, and that is also not an easy thing because the trip test is not well documented, I would say, and it's especially if you don't know tech, it's very, very difficult to wrap your head around what's going on. But eventually, I managed to get that going. And so then I could proceed with changing out parts of the implementation. And that was also more difficult than I anticipated because there's lots of interdependencies between the different parts of tech. Maybe if you've read the tech book, you know of the mouth and the intestines and different parts, and you think, okay, maybe I can just do these individually, but there's lots of interrelations. And of course, at times, it's also difficult to understand the nuances of the code. So the code is really well documented, but not every decision has been documented, right? Sometimes you sit there and puzzle, and often the answer is, oh, you save a byte somewhere. Sometimes it's also just because I don't know tech well enough, so I need to understand what it's actually supposed to be doing, and then I can understand the code. So this is an example from this is the original Pascal code. So this is a function procedure that essentially deletes a linked list. So P is a pointer to the head of a singly linked list, and it deletes it from this array of a memory array. So if in the first run of translating that, it would look like the following Rust code, and as you can maybe see, if just close your eyes a little bit, it looks very similar, right? So you have this unsafe keyword initially at the function, because almost every function uses some kind of global variables, so you needed that for basically all functions. And then you have the same variables, and it translates rather well. You have of course some changes. I don't think so it's not in this code, but in some codes I needed to have basically a go-to crutch, I call it sometimes, where you use a loop as to simulate a go-to statement. So a loop can have a label, and then you can break or you can continue to a specific label, and you can. It's a bit ugly, but it works sufficiently well for an initial translation. So as an example of interdependencies of these different parts of TUG, so when you read an input token, which is in some sense the first step that a program does, right? It starts with a line in a file, and it tries to understand the first token. So one thing it needs to know is what are the current category codes? Are we dealing with a single letter? Do we start with a control sequence? So it needs to know these current category codes, which themselves are, again, global variables that are bound by the semantic nest. So how deep are we nested? So there are scoping rules. You might cause an error. And that, again, depends on the global state. So this function might fail if you read the wrong token at a specific point in time of execution. This input routine might want to log to a file or write to standard out. And it also needs to access, again, a global variable. So for example, if you just finished a file, there's a certain variable that you can set where you can manually verify each line you read in. And so there's really just a lot of interdependency. And also, if you're basically in a table, maybe the alignment state can change. And then again, if you log an error, you need to know about what the current input stack is, because you might interactively add or delete from the input stack. And you need to know current definition of certain control sequences if you print the current context. So it wasn't really easy, or it's not quite feasible to really separate parts. And so what I ended up having in the end was 3 entities that are semi-global objects. So one is the logger, which is responsible for interaction with the user and printing to the log file and standard out. Then there is the EQTB, and this is something that comes from the original implementation. It's a table of equivalence, which is basically the store for all variables and their current state. And then there's the scanner, which is responsible for scanning input, for scanning the next token and maybe expanding it. So, and because these all have interdependencies, you often end up with methods that have a function signature like this one. So where you have, so this is just a small function that ensures that a list is empty when in math mode. So it takes the current list, but then you need to pass the scanner and the EQTB and the logger, because you might need to print an error or various different things. So that was unfortunately not possible to get rid of these. So it doesn't, it wasn't quite possible as I had hoped to separate concerns as much as I wanted to. So what is the current state of this project? So the implementation passes the trip test with a very minor caveat. There is one line that appears in a different space, just because I changed the order of 2 things. It does produce binary identical output, so I verified that on my computer with my Take Life installation. So when you adapt the comment strings, the version strings, and the timestamp to the exact same time as then you can get the binary identical output. So the code no longer uses global variables, and there's no unsafe code left in it. And I removed most limits, built-in limits of the original TUG implementation. So there is no limit on the number of control sequences or the number of registers or the number of strings. But I did leave some in because they're actually helpful when you're programming. For example, if you have a file that includes itself, you really want it to stop after a fixed number of steps and not before you run out of memory, right? So I left a few of those in. And in the spirit of the original implementation, I wanted to avoid any external dependencies. So it's a self-contained contained program. So there's a few buts. I was a bit naive about the performance initially. I was kind of hoping, with a modern compiler and whatnot, maybe some stuff gets faster. It did not. So it's currently slower by a factor of roughly 2. I don't quite know where this is lost. I have some suspicions, but I imagine it's possible to get closer, in any case, to the original speed. But I did get an appreciation for how well the original code was written. That even today, it's really fast, I think. So it doesn't have any integration with kpathia, if that's how you pronounce it. There's only hard-coded directories, so you can't quite use it as a normal TUG installation. You need to put the font files and the input files in very specific directories. There's no working timestamps, which is because I wanted to avoid adding an external dependencies, and implementing time facilities is quite cumbersome. So at the moment, it's I think it's always 1776 for the program. It's only implemented for Linux because that's what I run personally. There's no PDF output, and there's no epsilon TUG extensions, and I did not write a lot of documentation for it, so most parts of the code just reference the corresponding sections of the original TUG implementation. So if you want to check it out, you can find it on GitHub under this link, and yeah, thanks for listening.
Are there any questions for TUG? Yes.
My question is, I found when I wrote it from web to CWeb that my translation invalidated most of TUG's documentation. So the code was not longer matching the documentation that was in the CWeb file. You just reference the original documentation. How do you document the differences?
Yeah, that's a good question. So the answer is probably I don't. So far I've been working with it for myself, and it's a side project. So I focused on the stuff that is fun, and documentation writing is not always fun. So some parts did change considerably, and there's not a very good match between those, and others are almost literal translations still. So it really depends on where in the code it is, but it's not indicated in the code when it changed a lot.
Yeah, this is a hard part. When I started, I thought the documentation is the easy part, but it's a hard part.
But important for others.
I'm curious about were you able to leverage the Rust type system to somehow catch many bugs? And I was a bit disappointed to see that this was a pure rewrite, meaning the interdependencies were kept, which I imagine would essentially keep you from using most of the pros of using a type-safe and stronger type language.
So there are, let me think. So I know, I looked a little bit into implementing eTag, and I know I think there's a bug, a small bug, for example, where I can see, because I don't use global variables, that it doesn't pass, the implementation doesn't set a certain global state, which needs to be passed in the function signature that I have. But it's minor, really. So, I mean, TUG is really well written, so it's not easy to find bugs in it. So I think the main purpose of these is for myself, as it was for myself when rewriting it, And I think it can be utilized if you extend it, right? So let's say you want to add a new node type, right? You need to. There's many places where you would need to check that you handle those node types well. And I think that's where probably these types might be useful.
A question from Luigi Scarsa through YouTube chat. He says, nice talk. I'm a little surprised by the 2 times slowdown. It might be interesting to transpile a subset of the LaTeX base code into Rust, maintaining the code's recognizability. We need it to be in sync with the PDF code base.
So I didn't quite get the question.
It's maybe a question about the slowdown and the comments that they probably need to do something with LaTeX, because in LaTeX you have a lot of Lua, and it would be probably interesting to see what happens when you do something with Rust.
Yeah, so I can say so one fundamental thing that changed is that in the original implementation, all lists are basically linked lists, and I changed that to be dynamic arrays. So I now have, so that can be an advantage at times when you want to have just jump to a specific position in the array, but as a disadvantage when you just want to cut and slice these arrays. So I think that because the original implementation was of course tailored to these linked lists, there might be some efficiency loss in that regard, and I think this continuous parsing of these global structures that are probably not optimized away can be another slowdown of this code. But that's only guesses.
I think the last question.
You mentioned K-path-C, or Karl's path searching algorithm I discovered lately. If you can use the shell in Rust, you could call KPSE, which?
Yes, yes.
In order to just get rid of the static files for the moment. I don't know if you want to continue this project.
Yeah, I did actually try that out, and that works well. I mean, it's a bit slower because you get some, you call it again and again, but you don't call it that often. So I think it works for practice. That's a nice hack to very quickly, get integration with that. Yes.
And also, if you could static link, for example, K-path-C lib, you could do it natively, I guess, or with more performance.
I imagine, to be honest, I have not looked into it, so I don't quite know how complicated or easy it would be.
Okay, thank you.
Okay, thank you, TUG, for your talk. And then the last talk before lunch, DJ Werner.
Hello. Dear friends, exceptionally today I will start with the conclusion and only then will I proceed with the development. So to conclude this talk, I have implemented a large-scale TeX font metrics format in Common Lisp, and this system is currently running on the whole TeX Live distribution. It checks for all the TFM files that are present in the distribution locally, and it also generates a website which we've set up with the help of Norbert Preining very recently. So the URL is here. It's updated daily, and it currently spots a little bit less than 800 fonts with non-compliance issues with respect to the TFM format. Thank you very much. I will take questions now. No, just kidding. I have a little more to say about this project. So this project is actually a side project which I originally never intended to do. It's very young. It's less than one year old. And it's actually a side project for the ETA project, which I was talking about last year, for those of you who were here. It's my experimental typesetting algorithms platform written in Lisp, and for which I needed, one of the very first things that I needed was to bring the TeX font metrics information to the Lisp language. So I wrote a parser for this font format, which is very creatively called TFM. And so this is the library. It's a quite simple library. The interface basically boils down to a single entry point, which is a very creatively named function as well. It's called load font, and it loads a font. And it creates, so it loads a font from a TFM file somewhere on your hard drive, and it creates an abstract data structure in Lisp, which brings all the TFM information to the system. So basically, that's all there is to it. But the design of this library, for me, it's very, when I write a parser for any kind of format, I always try to be both robust and flexible. Robustness is something quite obvious when you write a parser. Flexibility is because I'm a sociopath, I'm a psychopath. It's a disease, but as we will see pretty soon, it also has some advantages. So what does it mean to be both robust and flexible when you write a parser? Because mind you, TFM is a binary format, but you're still writing a parser for it, even though it's binary. So for me, robustness basically means anticipate all the potential problems that could occur when you parse a file, binary or textual, doesn't matter. And be robust means that if you catch all the potential problems, then you can hopefully avoid crashing and or behaving, which is worse, behaving erratically. And so you can do something like, for instance, exit or give up gracefully rather than doing all kinds of nonsense. During the development of the TFM library, I identified 20 potential problems with respect to the parsing of the TFM format. These are, I insist on this is very important. I mean by that potential problems that are detectable when you parse the file. So for instance, incoherence or contradictory information that you parse, stuff like that. If the font is nonsensical in a way that you cannot detect, for instance, some character codes are missing whereas they should be in there is no way that you can detect that, okay? So there are a priori 20 different detectable non-compliance issues, and those issues come at various degrees of severity. Here are three very quick examples of this. Something which is extremely severe, so this is going to be an error and probably a non-recoverable error, is a truncated file, for instance. Okay, so if a file is shorter than the declared size, there is probably nothing much you can do about this font. It's not going to work at all, and that should be an error. Okay. Another kind of non-recoverable error would be invalid section pointer. So the TFM format has lots of tables in it and pointers and indexes into the tables. So if you have an invalid pointer to a section, it means that you've completely lost access to extremely important information. So there is not much you can do about this, okay, apart from exiting gracefully or giving up. Slightly less problematic, for instance, could be a problem in a ligature program. In the TFM format, ligature and kerning information is represented in some kind of very small and very simple programming languages, and it could be possible in a corrupted file that you end up with a cycle in a ligature program, which means that you would go in an infinite loop when using the ligature. Okay, so this is slightly less problematic in the sense that if you're able to detect that, you can just give up on the ligature program itself in the hope that the rest of the file still makes sense. Finally, there are some non-compliance issues which are not problematic at all. For instance, there are a number of strings in the header of a TFM file which are purely informational. So they are not used by the font itself. It's just there to give information to the reader, and that's all. So if you detect some inconsistencies in those parts of the file which are not used by the font itself, you can, for instance, just discard the information. It's not going to be a problem. Okay, so these typically should be only warnings. One final thing on the robustness matter. The interesting thing is that at places, the severity of a problem can be dependent on the context in which you are, or the time or the precise context in which you're parsing the file. A typical example of this is the design size in the font. So in TFM there is a number which corresponds to the design size of the font. There is a specification on it. It cannot be anything. It must be greater than 1, for instance. So if you parse a TFM file and you find a design size which is less than 1, that should be a warning or an error. So normally the font is not going to be functional because you cannot make any sense of the metrics, of the character metrics. Okay? The design size is important. But on the other hand, it is possible to override the design size. This is what happens when you load a font and you say font blah 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 at a design size, a precise design size. In that case, you have the possibility to override the design size. So suppose that you've passed a font with an invalid design size, but you are overriding the design size with a value which is valid. Then in that case, the fact that the original design size is wrong is not so much of a problem as before, because you're not going to use it. So in that particular situation, for instance, the TFM library will issue a warning if the design size is overridden by the user with a correct value, but otherwise it will trigger an error. Okay? So that's it for robustness. Now, flexibility, we come to the disease part. To me, flexibility when you write a parser is the idea of providing as many recovery options when you encounter a problem as possible, rather than just giving up. Okay? So you see why it's an arguable feature of a parser. Most of the time when you load a font and there is a problem inside, what you want to do is fall back to another font and just say, no, there is a problem in there, I don't want to do anything with it. But because I'm a complete psychopath, I like to add as many recovery options as possible. This is arguable, but again, as we will see, it has some advantages, especially when you want to write not only a parser, but a validator. A couple of examples of these. I've currently implemented a dozen or so recovery options in the library. Typical examples of recovery options that you could get would be, for instance, as I was mentioning before, discarding bogus ligature or kerning program rather than just giving up, in the hope that the rest of the font is going to be functional, maybe at the expense of a ligature not being present in the output anymore. But if you can still keep on using the file, maybe that's something that you would like to do. Another possible recovery option is fixing the first entries in the table. So in the TFM file, the widths, 8s, defs, and the Italy corrections table must start with the first entry of 0. It's, for the widths table, a way of representing a character which is absent from the font. So if you fall on a TFM file for which the first entry of these tables is not 0, probably the file is corrupted, but still in the TFM library, there is an option to correct the entry and set it to 0. Is this really going to work? You don't know until you experiment, but the recovery option is there anyway. Something very important to understand here is that recovery is black magic. Okay? For instance, getting back to the original point I was making, if a file is if there is an incoherency between the declared file size and the actual file size, for instance, if you find a TFM file which is shorter than the declared size, you can make the assumption that the file is truncated, but it could be that the declared file size is wrong and the physical file size is correct. But there is no way to tell. Okay? So you need to make assumptions, the most likely ones, and the ones typically hoping for the best. Okay? So this is really black magic, but it can still be useful. One particular area of usefulness of this is when you use the library in interactive mode rather than in a standalone application. Let me give you just an example of this. You might know that Lisp is it's a dynamic language, and you can either use it interactively in a REPL, or you can also dump standalone executables. So this is an example in which I've intentionally corrupted the CMR10 file. So here, normally the string which is here is supposed to read text. I've replaced the 2 letters with parentheses because this is supposed to be a BCPL string, and it's forbidden to use parentheses in those strings. Okay. So if you call the function load font interactively on this file, you will end up with that error. The BCPL string is invalid, and there you can see all the recovery options that are available to you. The obvious one is just give up, but you have also the possibility to keep the string as is, knowing that it's purely informative, so it's not going to be used anywhere, so you can just leave it like that. There is a possibility to fix automatically the string by removing the illegal characters and also replacing non-ASCII ones with question marks. There is finally an option to just remove the string from the final data structure, just pretend the string was not here in the first place. And something which I have not represented here is also the ability to interactively recover by asking the user to provide a different string, for instance, or to provide his or her own fix, rather than doing some automatic fixing like this. Okay? So if you're using the thing interactively, recovery options are good, because you can go as far as possible in the parsing without just giving up. Okay. The whole point of this design, when it comes to flexibility, which I was mentioning earlier, is that in the TFM library, no decision with respect to the effect of non-compliance issues is ever made. The whole point of TFM is to be exhaustive in terms of the potential errors that can come up, provide as many, that's for robustness, provide as many recovery options as possible, that's for flexibility, but the library itself will never make a decision with respect to what to do when an error is encountered, okay? So no decision, only options. Just for the fun of it, this is a complete graph of TFM's error ontology. The point of this is not to read and to understand the whole figure. The squares represent the potential non-compliance issues, so the 22 of those. The ellipses represent the recovery options that are available in the library, the ones that you could select interactively, for instance. But the whole point of this figure is just to convey the feeling that when you write a parser, even for a relatively simple format, being exhaustive in terms of catching errors can quickly become quite intricate. Okay, so developing a complete and exhaustive error ontology is not easy, and it becomes complex quite rapidly. All right. What does this have to do with validation of the TechLive fonts? So there is a second library written on top of this one, which also very creatively is called TFM Validate, and which is a TFM validation library for TFM files. So the motivation of this second library, the development of which started less than 4 months ago, is actually curiosity for me rather than necessity. I never felt the need for validating thousands and thousands of font files, which for most of those I never use and probably never will. But I was curious as to the status of TFM compliance on a large batch of files. Okay, and so that was the first motivation. And the second one is also because writing given the existence of the TFM library, writing the TFM Validate library was extremely easy to do. So I thought, okay, it's easy to do, it's going to be straightforward, it's going to take, I don't know, a couple of days, slightly more than that, but not much. So let's just do it and see what we get. And the key ingredient in that is a particularity of the Lisp language that I use, which is called the condition system. It's the Lisp infrastructure for handling exception. So what you would call exception handling in other languages, it's called signaling conditions and handling conditions in Lisp. So for those of you who know me, you know that I like to sneak in a bit of software engineering in my tech talks. So I'm just going to give you the idea of what makes the Lisp condition system quite peculiar and also extremely valuable tool for that kind of project. So if you've used a traditional programming language with exception management, you probably know about the usual try-catch statements, which are called with different names in other languages. Most of the time, there is a thing called try-catch, for instance, in Java. And the idea is this thing. So you have the call stack here, the func1 called func2 called func3, and you have a possibility to throw an exception, which non-locally will trigger something, maybe callback, something like that, signaling that there is a problem somewhere. If you throw an exception, it will go up the stack until it is caught by a try-catch statement, and that, if the exception is handled here, then the computation can resume from that point, okay? If the handler here is not concerned with the exception, or if it declines to handle the exception, it can continue its voyage up the stack until it reaches another one, and finally, the try-catch statement, which is at the upper degree, will have the ability to catch the exception and resume computation for here, okay? So this is a two-dimensional separation of concern, and in fact, it's wrong. Why is this design wrong? Because the try-catch statements in most programming languages out there do two different things at the same time, and there is no good reason for doing so. A try-catch statement is in charge of both catching an exception and restarting from there, okay? These are two different things, and there is, from a software engineering point of view, no valid reason, no legitimate reason for doing both of these things at the same time and at the same place. A technical reason, which is not legitimate either for this, is because all these systems are usually implemented in terms of a facility which unwinds the stack when you go upward. So if you reach that point and the stack has been unwound, there is no way to restart from down below. And this is the reason why those statements are in charge of both catching exceptions and resuming computation from the same place, okay? The Common Lisp condition system does it right. It has a three-dimensional separation of concerns. In this system, you have the possibility to signal an exception, a condition, which is the same thing as throwing an exception. You have handlers that have the ability to catch conditions, but the big difference is that when a condition is sent up in the stack itself is not unwound. So it means that you can establish restart points at different places than where the exception was caught. And in that kind of scenario, what can happen, for instance, is that the exception, the condition is signaled, it goes up, it's caught by this handler, but this handler is not forced to restart from here. It could, but because there is also a restart point established down below, the handler, which is here, may decide to restart from here rather than from here. If the handler here declines to handle the exception, it will continue its travel up the stack, and this one will see both of these restarts as well. So in that system, you have a 3D separation of concerns. Catching an exception is different from signaling an exception, but it's also different from the position at which you want to resume the computation. Okay? It's a shame that the traditional programming languages do not do that, because it's not complicated to do. This system is also based on setJMP, longjMP, as most of the regular exception handling systems that exist. So it's really a pity that not more languages do things like that. There is a second point which makes the TFM validated library extremely simple to implement, but this one is not particularly specific to Lisp, is that Lisp is also an object-oriented system. And like, for instance, in Java again, if you do exception handling in an object-oriented programming language, then you can implement the exception handling mechanism in terms of object orientation. So, for instance, creating the ontology of errors boils down to create a hierarchy of condition or exception classes. And then when you signal a condition or when you throw an exception, what you actually do is just instantiate a class, and you end up with an object in the object-oriented sense. Okay, so it works also like that in Lisp. What does this have to do with the easiness to implement TFM validate? Well, as I mentioned before, the TFM library only provides options but never makes a decision. Okay, so it signals conditions and it provides recovery option. In technical terms, what does this mean? It means that the TFM library, which is down below, will have the ability to signal stuff, and recovery options are just restart points. But that's all. And the fact that the library does not make any decision simply means that there is no established handlers in the library. Okay? Why is this relevant for us? Because if you want to create a validation tool, what you want to do is catch all the potential non-compliance issues, but continue the parsing as long as possible in order to catch other exceptions. Okay? So the TFM library, which is up there, is in fact, it boils down to creating a big handler for all the TFM conditions. It catches everything, and then its only job is to use the restart, the available restart, which will allow me to go as far as possible in the parsing, to continue parsing as far as possible instead of just giving up. But in order to do that, now you realize that there is no modification required to the TFM library. And that's because handlers may be elsewhere than restart points. And this is why this library was actually extremely easy to implement. Okay, I didn't have to touch the TFM library to implement that. Okay, so catch all conditions, select every time the softest restart, and then you have a validation tool. Okay. One more thing that I do is every time I validate a font, instead of just printing stuff on the terminal, for instance, I collect the conditions which are reified as first-class objects because it's object-oriented, and so all the function does. The function is called validate. It's here, validate font. The return value is the collection of all the conditions that were signaled, and then you're free to do whatever you want with that. Print them on the terminal, collect them into a list, or generate a website with that, for instance. Okay. If you add 10 more lines of code on top of this, you can easily validate a whole directory of fonts. Okay, it's simply a matter of calling the validation tool on every font in the directory and collecting all the conditions. Okay, and then after that, that's the point at which I thought, oh, that would be easy to apply this to the whole TechLive distribution because there's a large bunch of fonts in there. Let's see what we get. Okay, and so maybe a couple hundreds lines later, I have a tool which calls invalidate directory on the whole TechLive TFM directory of fonts and generates a website with the non-compliance reports generated in a human-readable form. And so let's look at the results now. So as I was saying before, in the TechLive distribution, you have approximately slightly less than 80,000 TFM files. I'm currently skipping more or less 3,000 of those because these are actually not TFM fonts, but OFM or JFM, which I do not support yet. I hope it will be coming soon. And surprisingly, at least that was a surprise for me, I found slightly less than 800 fonts with non-compliance issues. Okay, so I started to investigate those, and fortunately for us, what I discovered is that even though this figure seems quite high, there is in fact only 4 non-compliance issues which I found. 3 of those can be considered not so important, so warnings only, and only 1 of those is a true error, something that makes a font completely unusable. The first warning that I get very often is the file overflow warning. So it means that the physical size of a TFM font is larger than the expected one. The TFM format declares its own size, and so what you get here is a file that is larger than expected. Okay, so this currently affects 628 files in the TechLive distribution. This is only a warning because the fonts seem functional. The second reason I chose to make this a warning is because TF2PL actually ignores the junk at the end of those files, okay? Remember that this is black magic. It could very well have been the case that the declared file size would be wrong, okay? And in that case, I don't know what would have happened. But if you make the assumption that if there is a disagreement between the physical file size and the declared file size, then the declared one is right, you can hope for the best and continue parsing, okay? And it seems to be the case. The junk at the end of those files doesn't seem meaningful at all. I've looked at a couple of examples and I can't decipher what's going on in there. It's probably an artifact for some ancient files of padding to the next block on some, I don't know, some storage device or whatever. So it's not very clear what it is, but it doesn't seem to be really problematic. Second warning, sorry? Yeah, we'll get back to. I can answer that in the question and answer part because I've talked with Carl about this, and it doesn't seem to be, the situation is unlikely to improve. But more on this maybe later. Second warning: padded string overflow. So in the header of a TFM file, you have two so-called BCPL strings of a fixed length. So the strings also declare their length. There is one which is 40 bytes or 40 words, I don't remember, long, and another one which is 10 bytes or words long. But you do not need to use the full storage. So if you don't use the full storage, the trail of the string is supposed to be zeroed out. So what I call a string overflow is strings for which the declared used size is okay, but then instead of zeros at the end, you get something else, okay? So this is also a warning because it doesn't hurt. The strings are purely informational. There is 74 fonts affected by this, quote, problem, end quote. So you got an example of the error message which is printed here. This is also a warning because the origin of this problem is slightly obscure. I had a discussion with Doug McKenna about this. He thinks that the requirement to zero out the trail of a string was not there in the first place, but it was only added to PL2TF in version 1.3, which was probably 2 years after the initial release. But on the other hand, there is a paper from David Fuchs in a very early issue of the Tugboat, which claims that the string must be zeroed out, and it was prior to version 1.3 of TF2PL. So you don't really know. But the interesting thing is that this problem, there seems to be intentional abuse of the trail of the string. So for instance, many of the strings, such as this one, contain something which is meaningful instead of zeros. For instance, here, you see YNY Inc. So I believe that it gives you a very clear information about the origin of the font, okay? But it's not supposed to be here. So this is intentionally an abuse of the padding area behind the string, okay? So for that reason, I've decided to include the junk in the error message instead of just discarding it. Spurious char info, third and final warning that I got. This one is really is much more obscure. What I call a spurious char info is a character which is not supposed to be in the font, but still which is not completely zeroed out in the char info structure. Normally, in the TFM format, you have BC, which represents the minimum character code, EC, which represents the upmost character code, but you're not required that, it is not a requirement that all the characters in this range exist in the font, okay? So you can have holes in it. So if a character is non-existent, normally the char info structure is supposed to contain 0 indexes to all the tables. And there is no point in having something meaningful in this char info structure because the character does not exist in the font, okay? And it appears that in 66 fonts in the TechLive distribution, there are non-existent characters for which the structure is not completely zeroed out, okay? And we don't really know why. again, this is only a warning, because if you look at TF to PL or PL to TF, PL to TF zeroes out the character in question, and TL to PF just ignores those characters. They are not printed in the output. So regarding the question before, regenerating from TL to PF to PF to TL and vice versa would remove the problem. Okay, so this is then considered not really an issue. The characters are not going to be used, so it can just be a warning. Okay. And finally, there is one serious error, and this is the only one. This is called the fixed word overflow in my library. Many numerical values in the TFM format are supposed to be within the range -16 +16. All the character metrics are supposed to be within this range. So if you're not in this range, something is going really wrong, because you would end up with characters, gigantic characters or something like that, if you were to compute the actual width and height and depths and so on. Okay. But the interesting thing is that only 2 fonts in the distribution are affected by that. This is RF Sans Bold, and there is another one which is also in the same directory. So those fonts are completely dysfunctional. The character metrics are completely messed up, and this one, for instance, you see that there is a repetition of 92 times this error. So probably it means that the width, heights, and depth tables are completely corrupted. And in fact, this is a serious problem, because the font is unusable, and as a matter of fact, TeX will refuse to use those fonts. Okay, it says that it says bad font metrics. So this is a true error. Okay, so this is the real conclusion this time. So to wrap this talk up, as I was saying before, my original motivation for doing this was curiosity rather than necessity, and also because it was easy to do, so it didn't take me a lot of time, so I thought, what the hell, just do it. Is it going to be useful or not? At the risk of putting the cart before the horse, we're not sure about that. Carl has expressed doubts about it. And again, to answer the question, he said to me that several times he attempted to put some pressure on TFM maintainers to fix their fonts, but he never succeeded. So will this contribute to that? I'm not sure. Maybe the greatest positive aspect of this work is not to put blame on ancient content, but maybe act as a vigilante for a future addition to TeX Live. Okay, so maybe the newer material is more likely to be watched over and fixed if there is a problem, rather than doing something on fonts that have existed for decades. You know, we don't know. The other merit of this work, also for me at least, is to answer my curiosity, and it gives you a general overview of the status of a large collection of TFM fonts, and it's interesting per se to discover that although a large number of fonts seem to be affected by non-compliance issue, there is in fact not much in terms of irrecoverable errors, only one. And this error only occurs in 2 fonts in the distribution, so this is probably good to know. Okay, perspectives of this, obviously adding OFM and JFM support, which is not, it will require modification to the original TFM library. I intend to do that soon-ish. So emphasis on ish. I would like also to check all the other font formats because I'm interested in writing parsers for the other font formats in order to bring those font metrics to the common Lisp world as well. I've already started to write a parser for OpenType. There is certainly a lot of room for improvement in the website itself, and mostly for the output of the thing and the way to access the cross-reference information and to make it even more accessible and even more human readable. And again, as a partial answer to the original question, the TFM library is currently only a parser, but it would not be complicated for me to write a font generator. And then one way to fix the fonts, if the maintainers refuse to do so, would be to load the file and then write it back with all the errors spotted and fixed for those errors which can actually be fixed. Okay? And that is all I have. Thank you very much.
Thank you, DJ. Are there any questions?
Would it also be possible to do the report on TechLive like in a continuous integration way?
That would be an interesting thing to do, yes. Currently it generates a website and the website is just updated daily with a cron tab entry, that's all. Probably Norbert could, I'm not sure if he's still listening to the conference, but Norbert, if you can hear me, please do some CI with that stuff. Thank you very much for the question. Thank you, Norbert, for the work.
Thank you for the great work, but the main problem I found with TFM files is that characters that are supposed to be there aren't there, and that cannot be caught with your method.
Yes, exactly. Yeah, you cannot detect that
there
kind of
is
problem.
one in a math font I remember in a family, a Polish family. That's very useful actually, and the character is completely missing. But we can do anything about that.
Yeah, no.
Any more questions before we can get some food?
Is there a chance to do it also for virtual fonts, for this VF? And
I'm sorry, come again?
Is there a chance to use the same tooling also for virtual fonts, for the VF and VPL files?
Not now, but that's an idea. Yeah, I'm all for it.
Just enhancing your list of things to do.
Yeah, it's an ever-growing to-do list.
Out of curiosity. Okay. Thank you very much.
All right, thanks.
Then we go for lunch. Please remember the photo opportunity at 1:15. Please make sure we're all there. And we'll see you back after lunch.
I just want to put it so I wouldn't. Okay.
Okay, so welcome back everyone. I've been designated to chair this afternoon's session. We have a fairly long session before the next break, so without further ado, we'll start with Boris.
Thank you. Okay. I would like to start with plugging my own review in the latest TUG board. It's about Face and Interface Conference at Stanford 2023, where participants discussed fonts, scripts, scripting systems, and one of the thoughts and one of the things which was from this conference for me is that, yes, typography is an art. As an art, it reflects what people are doing. And it reflects our society, our politics, the way we think about us as people. And one of the interesting processes which is going on today is decolonization. A lot of people start to think about their traditions, about the things which is theirs and not somebody from outside, and try to rethink their place in the world. One of the things is typography. A lot of people started to think, what is our typography? How does it differ from the typography of empire where we used to be? Now, when we talk about Ukraine, there is a decolonization process where Ukrainians start to reassess what in their cultural inheritance is theirs, what is done by Russia, and what kind of and what parts of this legacy they should maybe reject or accept. It turns out that Ukrainian typographic tradition of course, it's close to Russia, but it Russian, but it has a lot of different features, different ideas, and a lot of quite Ukrainian things. On the second item here, you see the photos of Kyiv railway station, which was renamed recently. It used to be Leo Tolstoy railway station. Now it's Площадь Украинских Героев, the Plaza of Ukrainian Heroes. And you can see that the first that previously it used more or less Russian classical fonts all the way. On the second photo, you see the Ukrainian name, which was done by Bogdan Gdal. This is, by the way, the gay. This, by the way, the person on the second photo. He is the designer of this font, a very interesting Ukrainian font designer. And you see that the font is quite different. Of course, it's different because it's more decorative. But some things like the letter, Cyrillic letter "sha," it's quite different what it used in Russian, and it's taken from the old Ukrainian manuscripts. So I wanted to add something to it, and I wanted to add some typical Ukrainian font to TUG Live. Basically, I wanted to put it to C10, so it could be added to TUG Live, MikTech, and so on. So I needed some good Ukrainian font with good open source license, so we can package it, repackage it, and just to show the Ukrainian traditions there. And it turned out that it was not a simple things to do, because a lot of even free Ukrainian fonts are under licenses which forbid, for example, change or forbid some things to do. It's strange. I talked to Bogdan Gdal here about it for a long time, but I wasn't able to convince him, for example, to change the license of his free font so I could repackage it. It was rather frustrating. But there is a great font, a quite Ukrainian font, which has OFL license, and so it's quite suitable for packaging. And there is a reason for it. And I need to make some aside and talk a little bit about a great organization which is called Mistecki Arsenal, Arsenal of Art. For those who are fans of the English football team with the same name, let me remind you that Arsenal is actually a place where tools, weaponry, and so on are stored, and football team was because it was military arsenal nearby. But this Ukrainian organization decided to use the word in its original meaning. So Mistecki Arsenal is basically a place where tools and things for artists are kept. It's a great organization. It's a cultural center. It's an exhibition center. It's a museum. And it did a lot for Ukrainian culture. In 2011, they decided to make a competition for the best Ukrainian font. And the conditions for the competition were rather difficult. They wanted a modern font, but also traditional. And they wanted to be business-like, but still distinct and good. They put rather generous price for this. The first prize was 100,000 hryvnia, which was at that time about 10,000 euro. And for Ukrainian artists, it's probably, well, even for any artist, it's a quite considerable thing. And the nice thing about the conditions was that they wanted the font to be first renamed, so it would be Arsenal. And second, they say that the winner should be released under OFL, under Open Font License. Now, he is a winner. It's Andriy Shevchenko from Berdyansk. The font, and you can see it because you probably already guessed that the slides are written in this font. It's rather narrow. It's and this very space-saving feature. It has really good contrast. It's very clear, very easy to read. It's sans serif. To tell the truth, I like serifed fonts, but I understand that nowadays a lot of business texts are typeset with sans serif, and it's really pleasant and good. Because it was released under OFL, it was possible to improve it, and it was greatly improved after 2011 by different people mentioned here. They added a lot of Cyrillic signs, Cyrillic letters for languages other than Ukrainian and Russian, so you can now typeset Bashkirian or Tatar or even the Cyrillic Mongolian or a lot of other languages in this font. A lot of Latin letters were added, including very good support of Vietnamese with its crazy accents and multi-storied things. And it's now a very mature, very nice, and very good font. So what I did, I wrote LaTeX support for this font. To tell the truth, nowadays with font spec, it's embarrassingly easy thing to do. You just take font spec and add a couple of syntactic sugars. So if you just say use package arsenal, you can just use any LaTeX font switching command and not thinking about what's going on behind the scenes. The interesting thing about this font is that, it has the full developed swash axis. So usually when you have a font, you have basically only one swash, only swash font shape, but here you have normal swash, you have italic, bold italic, and somebody, I don't know why, but you have swash bold italic variant, and they all are selectable with this package with the text SW or SW shaped command as usual in LaTeX. It has some interesting currency symbols. Obviously, it has symbols for hryvnia, but it also has things like tugrik, tenge, Russian ruble, and it has some nice devices like Aldin floors and so on. So it was pleasant to add commands in LaTeX to access with nice letters. As an example, obviously everything before was in Latin, but here is Ukrainian typesetting. This is a poem by a great modern Ukrainian poet Serhiy Zhadan. As you see, using business font for poetry is probably not the best choice, but it does not look completely wrong, and I think that this typesetting is something which we can use, and I use it for some my own private collection of books of my favorite Ukrainian and other poets and writers. Again, there are some fonts, maybe Ukrainian, may be more suitable for prose. Some of them are commercial, some of them are free, but not completely free. But this font is good because it's very nice, very readable, and free. Now, MAF support. And this is the worst. This is something which I'm continue to think about and continue to do. Maybe the best thing about MAF support would be to just write an OTF open type format file with MAF for this font. And I would do it if I were an artist or if I knew how to write, how to write open type files. I should learn it, but I don't. So presently what I did a couple of different attempts. They all are options in the package. First attempt was I took letters from the Arsenal font. I added some math symbols from KP Sans. KP Sans Light, actually, the font is very light. And you see it in the first example. Somehow it does not work with ZTech, because ZTech, I think it's a little bit buggy, and when it tries to use text fonts in math, the spacing is completely wrong. The second attempt is to use Ivona Light, completely for letters, for science, and so on. It looks more or less okay, but the third thing is I took KP Sans Light and just everything in KP Sans Light. It would be good unless if you see the difference between 2-story and 1-story A in math and text mode, it irks me a lot. So right now I have more or less possible solutions for math, but none of the I'm still not satisfied and still thinking how to do math right. To tell the truth, there are not many sans serif math options in TEG. I even had some discussion on the LaTeX free list, because people say that, oh, do we really need sans serif math? And I think there is a place for sans serif math, and it would be nice to have a good sans serif font with sans serif math. So a little bit about the use of font. I was absolutely stunned, surprised when Gutenberg chose Arsenal for their font of the month in November of the last year. What they do with the font of the month, they take the issue of the journal and typeset it completely in this font. Could you please switch to the second file, if it's possible here? I just want to show you how it looks. I was absolutely, just a moment. This is the first page, and if our great AV people I probably can show you how it looks in the journal. Oh, here we have it. Let me see. I just want to turn the pages. You know, I have this journal. It looks so nice. I shared this issue with Andrei Shevchenko and the other people who improved this font, and they were happy to see it used. And you see that even with some math, TXZ, and so on, it looks right. Yeah, he uses this font in different things. So you see that when you use this font in real use, in long texts with different levels, it's not bad. So we are now in the age of decolonization, of creating a big garden of different cultures, different attempts of different ways to think about us and our place. And I'm really glad that in something very small, in typography, we were able to do some contribution to it. Okay?
Yeah, just a comment. You mentioned that there are not so many sans serif mass fonts available. Well, there's a version of Lato, or it's now called Lete because of licensing issues. And I think there's also a version of Noto songs. Well, it's maybe not released yet, but it's worked on. So there will be more options of sans serif mass, but I don't know how it works together with this font. So you would have to try it.
Yeah, thank you. I actually tried to use Lata with Arsenal, but Lata is heavier and the math just did not blend well with the text because I need just light sans serif and it's not easy. Yes?
This question is also about sans serif font. Excuse me, was that specifically thinking of readers with dyslexia, or is it another reason?
Excuse me, what is it specifically?
Were you specifically thinking about readers with dyslexia, or was it for another reason?
It's a very good question. I don't know whether sans serif is really better for dyslexia. I wrote a paper quite some time ago when we measured the serifed and sans serifed font and how they are read by people, how well they are understood and quick. And our main result was that there is no difference between serif and sans serif. So I would think that sans serif is probably not better for dyslexia, but I cannot think about research here offhand.
Okay, maybe I'll ask you more later, but thanks.
Yeah, thank you.
Linking to Didier's talk, Ivona misses some characters in the math fonts. So if you try to type a norm with your Arsenal font in ZTech, you get nothing.
What happens is that here I stole a trick by Frank. He actually patched Ivona to get Norm and some other characters from other fonts. And so in a version which is used here, we use this trick, and so now it's complete. Thank you, Frank.
Any other question?
You talked about the decolonization trend.
Yes.
I was wondering, do you have some references for that topic?
Yeah, yes. In the latest tugboat, you can find my review of the conference face and interface. The people there were specifically about this. And it's a lot of very interesting works. For example, there is a company which creates fonts for Native Americans in Canada and US, and they have quite interesting work. So maybe the simplest thing, just read this review and go by the links and mentioned there.
Thank you.
I might ask one. In the sample that you showed, the poem, but I didn't have my glasses, but I was under the impression that some characters were a little bit heavier than others. It's just my missing glasses, or?
I don't know. I did not find this, but I'm not a trained typographer, so my eye might not be as good as somebody who is doing this all their lives.
Anybody else?
Just as we touched the topic of dyslexia, unfortunately the problem is that no font works for every dyslexic. Like every dyslexic has unique needs. Some people love Comic Sans, some people hate it. Some people love Antiquatorunska, some people hate it. Some people are happy with Times, which is completely ununderstandable to me, how someone with dyslexia can be happy with times, but there are such people. So the problem with these people is that you need to provide a way how they can change the font to anything they want, basically. So that's the challenge, actually, if you want to be dyslexic friendly in any document, is how do you do it on the fly so that the people can access it without any problem?
Yeah, we probably need, I think that the research can give us some pointers, but I would not be surprised if the answer is what, Tom, what you just said, that there are not much solutions.
I'm just relaying a comment on the YouTube channel about the missing characters in the fonts, and the example of the norm character. So there is a comment from Michael Sundquist who says one can also duplicate the bars to get the norm. This is done in context and in some other fonts.
Yeah.
That's all.
Yeah. Absolutely. Yes, absolutely. We can use some LaTeX tricks to overcome the missing characters.
Okay.
Thank you.
Thank you, Boris. So our next speaker will be Vit. He'll talk about Markdown themes in practice. So Vit, the floor is yours. So we're starting 5 minutes early. I don't know if we should give him 5 minutes more, or who uses the 5 minutes, but we'll see.
So thank you for the introduction. I'm Viet, and this is my talk titled Markdown Themes in Practice. There have been a lot of great speakers today, so it's definitely a high bar, but I'll try my best. So let's first break down the title of my talk. So what does it mean? So Markdown, as many of you will know, is a lightweight markup language that is easy, or that is supposed to be easy to both read and write. Unlike TeX, Markdown has no programming capabilities, which keeps things simple for the authors. However, TeXpers can style Markdown elements using TeX macros. For small style sheets, they can do it just like this. But for larger style sheets, it's useful to use so-called themes, which allow the TeXperts to express those large style sheets as program modules using the principles of structured programming. In my previous talks and articles, I used simple examples, and I spoke about the themes just in abstract, which make it difficult for readers to actually understand how they would use them themselves. However, since last summer, I have been working with the International Software Testing Qualifications Board, ISTQB, and I have been developing complex Markdown themes which they use to typeset their documents, and they allowed me to share the code with you. So in this talk, I'm going to go through an actual real-world example of a Markdown theme so that you can see why and how you might use it yourselves. First, I will go over the ISTQB project so that you can understand the scope and the requirements. Then I will discuss sort of motivating examples, how an author might use the theme and what they may get as an output from TeX. And then in the second half of my presentation, I will discuss the actual implementation so that you can see what actually happens behind the scenes. So In my project, I developed a LaTeX document class and 6 Markdown themes. The themes themselves, or the document class, is what you might expect. It's just a simple LaTeX 2e document class. It defines the LaTeX markup. And the themes are written in the Expl3 programming language, which was developed by the LaTeX team and which is used in the LaTeX 3 kernel. And they are used to process YAML and Markdown documents. So the base theme is called istqb/common. It enables Markdown syntax extensions, and it also defines the mapping between the Markdown elements and the LaTeX markup, which is defined by the document class. It also exposes to what we call, or what I call, snippets, which are basically a public interface which the authors can use to interact with the theme. So one of them is called metadata. This one is used to load YAML files with document metadata, and also language, which is used to load YAML files with language definitions, so that there can be different language mutations of the same document. And all those other 5 themes are based on this theme. They inherit all the implementation and also these 2 basic snippets. Let's skip these 2, the istqb/syllabus, the istqb/body of knowledge. They are basically just aliases for the common theme. They don't really add anything especially useful. They just have the name of the document type which they typeset. The document type which I'm going to focus on is sample exam documents, which are encapsulated in these 3 themes in the right bottom part of the picture. The istqb/sample exam theme processes YAML files with question definitions, and then these istqb/sample exam questions and answers typeset either lists of questions or lists of answers based on these YAML question definitions. And this will be sort of the focus of my talk. This will be my example on which I'm going to show how Markdown teams can enable this. So as an author, you would prepare a YAML file such as this. So this is a YAML file called questions.yaml. There is a list of questions. Each question has a number. There is some metadata, such as the question text, what is the answer to life, the universe, and everything, a couple of possible answers, then a designation of the correct answers, and some explanations which the learners can use to find out why the correct answer is the correct answer. And just for a good measure, here are two other questions, so that it's not too trivial. So two other questions. What's France's capital? And which 2 of the following animals are classified as mammals? You can see that there can be multiple correct answers, and the Markdown team will have to sort of grapple with that. So next up, you would have this LaTeX document. This LaTeX document would import the theme questions. From this theme questions, it would import the snippet called questions. It would assign it as a shorter name. It's not clear why here, but in Tugboat you really have just a narrow column, so just to fit the Tugboat format. And then inside the document you load the questions.yaml file with this snippet, and this will produce this output on the left part of the slide. So a list of questions. Then you might have a different LaTeX document where you would import the answer key and answers snippets from the theme/answers, and you would invoke the snippets on the file questions.yaml like this, and this would produce the answer key and the list of answers, which you can see on the right part of the slide. So from the standpoint of the user, this is quite nice. You just define your questions in a structured way, and you have a small LaTeX driver file, which is quite easy to read, and you get quite a satisfying output. The ISTQB was quite happy with this. So let's talk about how this is actually done in the team. So I'm going to focus in the preprint, which you can find on the conference website. I'm actually discussing, I discussed the entire code of these three themes, the ISTQB/sample exam star themes. In this talk, I won't have that much time, so I will focus just on this ISTQB/sample exam theme, which just processes the YAML file with questions and stores it inside macros. And then the actual typesetting, which is format specific, is left for you to read on in the preprint if you're so interested. I think this is like the most interesting part of the themes. Anyways. So this is how the snippet questions is defined. The snippet enables the processing of YAML files because it's a markdown package. Usually when I say markdown input, it expects that it receives a markdown file, but markdown files tend to have YAML metadata, so sort of naturally it's also able to process YAML files. So we just tell it there can be YAML metadata, and if it looks like YAML metadata, assume it's YAML metadata, and if the whole file is just YAML metadata, then it is. So in the future, we'll probably have a YAML input command which will do this automatically for you, but for now, this is how you enable YAML input. And then you say, then it reads the first field of the YAML file, and if the name of the field is questions, then it sort of calls private snippet called questions/list. By calls, what happens is it opens a tag group, and it says at the end of the element, enter the tag group, but before that, run this snippet, which means that until it reaches the end of the questions, it will be affected by the changes which are done by this snippet that I'm going to discuss on the next slide. So it's sort of this sort of does everything, but it's broken down into a lot of smaller snippets so that we don't have to we don't end up with indentation hell. We could also do it like in a one large snippet, but that's really difficult to work with. So this is the next snippet. It reads the actual question numbers and it stores them into a expl-free data structure. It stores them in a sequence so that we know which questions are actually stored in the YAML file. And then it calls the snippet sample exam /questions/star. And here it becomes actually interesting. Here we are actually reading the actual fields of the question. So if it's just an unstructured field, such as the number of points or the question text, then we pass it to a expl3 key value so that it processes it as it sees fit. I will show that on the next slide. And if it's some of the structured fields, such as answers, correct, or explain, or just these two, then we call subsequent snippets which process these. Here I say call questions/star/answers or questions/star/correct. What I mean by that is this magical formula which I used at the bottom of the previous two slides, which basically says call this snippet locally within this element But once we have returned from this element, sort of forget about the changes from this snippet, we are likely going to have some syntactic shorthand for this in the future. I discussed this more in the preprint, but here, because I don't have enough space on the slide, I just said call the snippet. I think it's even more readable this way. So what happens with these simple fields, which are unstructured, is that they are passed to a simple expl3 key value, and it just stores the values into property lists, which are keyed by the current question number. So, for example, this property list under the key 1 would store the learning objective for question 1, and so on. For the structured fields, for example, the correct answers, here we store the correct answer letters in a dict or a property list, which is keyed by the current question number. So it's a comma list. So in this property list, we would store under the key 1 just the letter B. But if there were multiple correct answers, it would be a list of all of them separated by commas. And we do the same thing for the list of possible answers, but here we also have an extra property list which stores the correct answers and is keyed by the question number / the answer letter, and the value is, for example, 24. So there would be 1/A, and the value would be 24. So this basically concludes the snippet. After it has run its course, we have a sequence with all question numbers. We have a property list with all the unstructured values, such as the learning objective or the number of points or the question text. We also have the property lists with possible and correct answer keys, and also the answer texts. So this is all you need to actually typeset the list of questions or the list of answers in the subsequent themes. Like this. As I said, more information can be found in the preprint. And this concludes my talk. So for many authors, TeX can be kind of difficult. Markdown and YAML can make it possible for them to reap the benefits of TeX without having to use TeX as an input language. In this talk, I show how experts can use Team to write large style sheets for Markdown and YAML documents. Many thanks to ISTQB for allowing me to show the themes that I developed for you, for them here to you. And if there are any questions, I'd be happy to answer them. Thank you.
I also try to do some YAML, and then in preamble style. For example, I tried to inject the YAML metadata into, for example, hyper setup, but that's at a preamble stage in LaTeX. So I ended up using Lua script, but I wonder, maybe you know of a way how to leverage the Jekyll data into the preamble of LaTeX documents.
Yeah, the Jekyll data option of the Markdown package can be used in the preamble as well as in the body of the document. So unless the renderer macros, which actually produce output, do something which is not allowed in the preamble of a LaTeX document, then it should be completely permissible to use them. In fact, the metadata and the language snippets, which I showed earlier, these are typically used before begin document within preamble. So it shouldn't be an issue.
I wonder, do you have access to the Markdown or the TUG code to change this, or that would have to be done in the template then? Suppose I want a column less, what do I have to do? So you now have nice answer sheets, but I don't want one of the columns.
Yeah, in that case, I suppose you could change the snippets, since in the Markdown themes the snippets are really the level of abstraction that is useful. You might want to redefine these snippets.
And then another question, presumably, so you use R Markdown to program this, but it presumably could also be done in TUG without any Markdown, because we didn't see any Markdown in the trivial case. The document doesn't contain Markdown, and the end user is not concerned here with Markdown.
Yes, so the example here was a YAML document, but you could, truth be told, I'm not exactly sure what the question is. Is it because...
Could I adapt this, or use these same YAML files to produce TUG things where I don't want to use Markdown to add the text, but pure TUG. So I would want to have a TUG document and insert questions from these YAML files. Would that be possible?
That would be possible. If you're using LuaTeg, there is the package called oh God. Yeah, there is the package the Markdown package uses to load YAML is available on C10. So you don't need to use Markdown package. You can just use Lua to load the YAML file and do anything you want with it. If you don't want to use the Markdown package, that's possible.
Okay, thanks.
Tiny YAML, yeah, thank you.
Yeah, I had about the same question because the Markdown was in the title, but I think we have the same idea, is that no Markdown was used there.
Well,
or could the authors use Markdown inside the questions?
They actually can. That's how it currently works. It's not useful everywhere. It's usually useful. So we are planning to give an option to disable it, but currently all the text fields in a YAML file can contain Markdown. So they can actually use Markdown markup inside the question text, the answer texts, the explanation. So they actually can mix up Markdown and YAML quite naturally.
And I alluded to this earlier in my talk. In Markdown, it's very nice to do simple things. It becomes complicated as soon as you want to do complicated things. What if some author of a question needs, well, one classic is that how do you center text? It's not possible in Markdown to center text. Or how do you use math inside a question? What would be a solution there?
Yeah. So Markdown was created as a preprocessor for HTML, and in HTML the answer is attributes, and we support attributes. I actually wrote a tugboat article like the previous year called Attributes in Markdown. So you can actually give a set of class names which the authors can use to make some changes. You can also use raw TUG input if you want to allow that to your authors, for example, to create some more complex typographic material. So there are options.
Okay. Any other question? Because I said we were 5 minutes early, now we're 15.
Was there a special reason to give a label of the question? Because it looked like it was just in order, so I would expect a list then, I guess.
Yeah, it was part of the requirements so that you can have holes in the numbering scheme. Really, no reason really, other than that.
I usually try to not give comments instead of questions, but since we have a lot of time, maybe there is a field where what you are doing is really important. And this also was mentioned in Vincent's talk. A lot of people use Markdown in the packages like Swift, Nitr, especially the Nitr with R. And basically what they do, they write things in YAML like document class, colon article, title, so on and so on. And then they have some either R functions or some functions to translate this YAML into TEG, and then Markdown codes to translate TEG, and it's a lot of mess. So I think that a package like you might be integrated with Knitr and other things to make it a little bit more streamlined and a little bit cleaner that people are doing right now.
Yeah, should I respond? Yeah, I'm not terribly familiar with Knitr. I know in general what it does, but yeah, even with given my limited understanding, I think that you could like skip one of the steps, and instead of generating TEG from Markdown, you could just compile some driver file which would process the Markdown internally.
Maybe a question for the organizers. Does it matter if we start early for people online, or?
That's a fair question. I think 10 minutes is maybe too much. I think that if people want to join a talk, that maybe 5 minutes early they might be in the stream, but not 10. But I might use this opportunity for a very little announcement, if that's fine. But I think we should thank Wade for the talk. So there is actually 2 announcements, I think. One of them is that there is the banquet tomorrow. We are still able to make adjustments. So if someone didn't register for the banquet and would be interested in coming, please contact me on the coffee break today. I think that's the latest chance to do that. So that's just one announcement, and we should still be able to squeeze you in. The other announcement is about what's called excursion on Sunday. Please, there is no limited seats. The church has 200 seats, and which the concert's gonna be. So don't worry. There is no entrance fee. So even if you didn't register for the concert, we would still be interested in some nice Baroque organ music, and not just Baroque, by a very, very nice person specializing in authentic interpretation of Baroque music. Then definitely come in, and I think it's going to be a lot of fun. So that's the 2 announcements that I had, and I don't think I have anything else. But if you have any questions, then I'm here, Michal is here, so you can always reach us. Thank you. And I think we can start in 4 minutes, maybe, or 5 minutes, or just get back on schedule. Yeah, maybe we can get back on schedule. Yes, right. Yeah.
Okay, so we resume at 2:30. Okay. So you're the only one to present?
Yeah.
You're the only one presenting? Okay, so the risk about unanticipated breaks is to get late. So we'll start right away with our next talk by Wim Obels.
Good afternoon. I will try to share with you the next half hour my enthusiasm for Chimera when I found out about it 5 years ago. So that's the main purpose. Chimera stands for Chimera Interactive Mathematical Educational Resources for All, so it's in the same style as GNU and Linux, recursive algorithm. It's an open source platform hosted on GitHub, and this QR code brings you there. If you get bored by my talk, you can, and might be interested in Chimera, you can go to this URL and get the live version of what I am going to show, unfortunately only in PDF, because we make web pages, but I can only show you here a PDF. So the main thing is that it supports authoring, publishing interactive educational content. So this is textbooks and online courses. It does this both in HTML and in PDF, so not only PDF, not only HTML, but both. And importantly, you just write LaTeX code. Yeah? So there's nothing else for an author to do. The ultimate goal, according to the Chimera people, is to promote sustained student success and saving by having all this available in an open source, free form. What does it do? Very easy. You have begin enumerate, end enumerate, and the only thing for this trivial example is that Chimera gives you one new macro \answer, which contains the answer. And from this LaTeX source, we generate 3 things. 2 of them can be done by lots of things. Namely, we generate a PDF worksheet with empty answer boxes. It generates a solution manual with filled-in answer boxes. But importantly, from the same source, it generates HTML pages where the student can enter their answers, and they are validated, and they get feedback when they are correct. Not from this simple source, but I will explain immediately. You can also give hints, you can give complete solutions, and so on. And all this is stored in the TeX file, yeah? And in the PDF, you can choose which sections you want to print or not. Yeah? Whether you want to have the feedback inside the manual, the printed manual, or the hints, or the solution, and so on. What's the history of Chimera? In 2010, Bart Snap from Ohio State University made something, I don't know what it was, to migrate LaTeX code to generate some kind of app on the iPad for interactive mathematics. 2 years later, his colleague Jim Fowler, also at Ohio State University, developed in the hype around MOOCs, a very popular MOOCulus, MOOC on calculus. It's still live, yeah? And based on these things, they got a grant from 2013 till 2016 to develop some kind of interactive workbook, textbook, and they wrote a Chimera class in LaTeX, and they developed a web server and some supporting tools to get this thing working. By 2016, many courses already were existing. Since then, I think around 100 or more than 100 courses are live. 10,000 of students have been following these courses, and they are used at 12 institutions at least. Yeah? But importantly, they are in fact all hosted at this chimera.osu.edu website, except for the University of Florida, where they had collaborator Jason Noel, who took the open source code, and developed it a little bit further, and they added some functionality. And so the University of Florida today has a variant of this Chimera website specific with some added features. In 2019, Jesse Holbergs, my colleague, and I, at the University of Leuven in Belgium, were looking for a system to convert existing LaTeX files for normal courses, for self-study, and to make them available online. We walked around a bit on the internet, found lots of things, and I got interested in Chimera, so we chose to develop these things in Chimera. And it worked quite well. The funding of Jim and Bart stopped in 2016. Development stalled, essentially. It's fully functional. I said there's tens of thousands of people using it. But there were only bug fixes after that. One of the main things we had to do was, in Belgium, people speak either French or Dutch. We are in the Dutch part, so we needed a Dutch interface. So the first thing we did is to translate all the hard-coded labels and so on in Dutch. And that's why we never really contacted the people of Chimera themselves, because there was not a lot of changes over there, and whatever we had done would not be usable anywhere else because it was hard-coded in Dutch, because we quickly had to make a proof of concept to our powers that be to make sure that Chimera was a viable solution. But things have changed, because in 2024, Jim and Bart, who are the developers and owners of Chimera, the open source project, they got a rather important grant. And so right now there is again money to do actual development. We got in touch a few months ago, and we are now in the process of integrating whatever we did in Chimera with what they plan to do next. This is what I will also talk about. So this is what a course looks like on the Ohio website. So there's a menu at the top, and each menu option gives you one topic. In Chimera, it's called an activity, and this corresponds to one TeX file. Yeah? So each web page is one TeX file, and a course is a selection of TeX files. Exactly the same TeX source, yeah? Literally exactly the same one, shows this one at our server. Yeah? So we changed the layout with CSS and so on, and we get exactly the same. What do you see? There is support for some kind of environments. For instance, here the remark says that it's advisable to also view the PDF version. Yeah? And I will show you the PDF version immediately after. You can get definitions, and here you get interactivity. So here you have to enter exactly the solution. Here with this key, you don't have to enter it because you can also show it. This we use if the answer is very complicated to type. And here, reveal answer is if it's so complicated that we don't even want students to try to enter it. It doesn't make sense. You just show the answer. And this is a drop-down box. So it pulls open, and you get multiple choice answers. We can integrate, well, when I say we, it's always unclear what I mean. It can be we Chimera, or it could be we at Leuven. Yeah? Here it's we Chimera. Can also integrate all kinds of interactivity. So here there is a link to Desmos, which I will show you immediately in the text source. It's just /graph y equals cosine x. You get this thing, and end users can, as with Desmos, just play with it and use it. So this is the website when you open it, and this is the website once you start filling in answers. This is the PDF. So at the top there is a download button. There is, in our case, always 4 files you can download. You can get this web page without the answers. You can get this web page with the answers. You can get the complete course without the answers, and the complete course with the answers. All these files are completely automatically generated, yeah, so we don't care. I will show you how we do it. Whenever one pushes a new commit to the tech repo, 5 minutes later, the website is updated with all dependent tech files. So this is the PDF. It looks quite the same. Yeah? This is because we took care with the CSS styling and the PDF print style commands to make it look like. But here you see that in the remark, it says it's advisable to also go to the online version. And it says, by the way, you are using the handout, which does not contain the answers, but this PDF says you are using the standard PDF, which does contain. So we can make slight differences between the different versions of the LaTeX. This is exactly the same page, but now it's part. So this is one of one. I download just this one activity. It could be a worksheet, for instance. For an activity, it doesn't really make sense, a lot of sense to print one page, but for worksheets it does, because you could give them handouts. They are automatically included in the complete course, and for instance, the numbering is different then. Yeah? Because if we print one page, it doesn't make sense to label it definition 111, because it's definition 1. But if you include it in a course, then it gets the correct number. If you include it in a different course, this particular activity could, of course, be 2.7. and so on. This is the tech code. So it has a document class Chimera, which is an extension of article. Yeah. It defines some extra environments and some extra macros, and it changes some of the functionality of tech. Yeah. One of the nice things is that this activity is an independent LaTeX file. Yeah? PDF LaTeX of this file will generate you PDF. The LaTeX classes are in CTAN since a few months. Yeah? So anyone who has a recent tech live or recent tech can just copy-paste this and it will work, it will generate a PDF. The next thing is input preamble.tech. So whatever is not in the Chimera class, we put in a preamble, which is included typically in all the activities and also in the course. So with a preamble, the idea is that the Chimera class, you do not change, yeah, you get it. But in the preamble, you can define additional macros and additional environments and so on. One of the things, for instance, we did is the official way is to have an author, a title, make title, and a begin abstract, and we made a shortcut, XM from Chimera title, which does it at once. Yeah? How do we do the slight PDF differences? It's an atypical usage, because normally the PDFs are identical to the HTML, but if you want to make a difference, you have the command PDF only, which only works in the PDF, and for some reason I do not really understand, begin online only, end online only if you want it to be online only. And then there are some variables, if handout or else. Yeah? In handout mode we say this is the handout, and in non-handout mode we say this is the standard version. So this is slightly advanced usage if you want to make small differences between the two types, or 3 or 4 types, whatever you want to define of output. Then you get the normal definition, nothing special. There is the environment, begin exercise, end exercise. This one is special because the web server that goes with Chimera does know about these environments, knows that it has questions in it. And so Chimera has an LTI integration. It's integrated with your learning management system. And the results of a student answering this will go back to your learning management system. Yeah? And there you will know that on question 1, he answered 5 out of 6 or whatever. So the first example, begin question, is \answer. That gives you in the PDF a square or dots, you can choose it. It's a macro that you set. And if it's answered, you get it with a square around with the solution, or you get it in blue or whatever you prefer to set. If you add the option online show answer button, then in the online version, there will be an extra show the answer. Yeah? You do not have to type it. And if you say online no input, that means that you cannot input it online because we do not want people to try to enter all these digits. So these are options you set in LaTeX. To have a multiple choice is easy. There is the command \word choice with lots of \, choices, of which at least one is correct. If there are two correct in this setup, both will be considered correct. There is no way to select them both with a drop-down. But you can also, except for word choice, you have also multiple choice, or select all, where you have multiple choices. To integrate graphs, decimals, it's as easy as this. Yeah? \graph with some options, how big you want it to be. Well, how big you want the axis to be, and you display the y cos x. Remark that here we are independent of nothing. Yeah? In the sense that if the Decimals website is up, nothing has to be saved on the Decimals website because we can just give the commands. The same thing happens, well, we also have links with GeoGebra or YouTube or Google Docs or KCCD, the comics thing. Yeah? All this can be just linked, but then, of course, you link to something that exists. Also for GeoGebra, if you make an applet, you have to provide here the SHA of the GeoGebra thing. What's then a course? A course, so Jim and Bart were very fond of the axes, and so with Chimera, they also made courses, rather than courses. So there is a document course, which includes the same preambles, which can set some variables. I forgot to note here that if you print the complete PDF, you get a QR code, which is a hyperlink to this particular page on the website. Yeah? So for instance, for answers, yeah, it's very convenient to not give solutions to the students. They can just push on the button and they come on the website where they have all the interactive explanations and so on. This is decided here, print activity QR coded through. If I set this to false, I don't have the QR codes. Yeah? Here I have print part front page false. Do I want to start each part with an empty, nice front page with a title, or don't I want it? There are tens of variables here that you can set, which are all defined in the print style and the preamble over there. The difference between the print style and the preamble is that the preamble is used always. The print style is only used when we produce PDFs. For instance, page layout and so on doesn't make sense in the HTML version. And so in the @print style, you can use things that do not really make sense on HTML. For instance, all the environments are done with T-color box, but on the website we don't want no T-color box because HTML gives much more freedom to style things correctly. And important point, such a course is very, very easy. It's just a list of activity chapters that you want to include. Yeah? Which are the files. So the file I showed you is called theorie.tech. There's another file, exercises.tech, and so on. So composing a course is a trivial business. The way we set it up at KU Leuven is that we now have hundreds of small files, derivatives, chain rule, and so on and so on. Yeah? And exercises such and exercises so. And people who are interested in to provide background information, or typically we use it only for, or up to now, we only use it for entering students. So the content we have in Leuven is about high school level mathematics that we assume known. But it's very easy to compose a course by saying, I want this, this, and this, and this topic. Yeah? You commit it, and 5 minutes later, you have your own URL, which specifically for your course is valid. And we use Git. You can either choose to put it in a different branch, and then you're completely responsible for updates of all these files because you have your own copy, or you can keep it in the main branch, which means that if we correct some mistakes in here or improve, you will get them for free. It's up to the user to choose which thing he wants to do. the whole structure looks like this. So it's a Git repo. You can't use Chimera without Git. Typically, all the content is organized in folders. Authors stands for authors, the demo, Git, and so on. The demo.tech is this file. It's the course. Yeah? And I also have a test.tech, which is a different course which contains less or more things. One of the nice things is that everything compiles out of the box. Yeah? Your activities are standalone tech files. You don't have to input, include, whatever, you just PDF LaTeX them. And also the course includes them. Yeah? The trick here is to redefine input to ignore everything that's before the begin document. Yeah? So that you can just include complete files. You see that here is the print style and the preamble. And we set up also these files by now in Leuven are very complicated because most of the structure, almost everything we did on top of what Chimera provided is done in this preamble and print style. It's some not completely trivial tech, yeah, which is not for the typical end user, but some of the variables can automatically be overwritten by the global.style. So this is a very simple file which can, for all your repo, redefine some of the variables. The global.css allows you to change the CSS. Yeah? If you want the definitions in red rather than green, you change the CSS. And if you would put demo.css, this demo.css would override the other defaults, and so for the demo course, you would have a different layout. Yeah? So you could make it that it's clear for students which version of course they are using. The last thing is the GM LaTeX, about which I will talk now. So this is a small example of what hints and solutions look like. So this is if you enter the page, and then if you click on hide hint or hide solution, it's shown or not shown. Unfortunately, I'm not being able to show it to you because I only can show you old-fashioned PDFs during this presentation, but it works live. So, and the only thing you do in tech is begin hint, end hint, and for some stupid reason, we put this in Dutch, begin oplossing, end oplossing, but this begin solution, end solution, that also works. Yeah. It would be very nice with the previous talk, yeah, to be able to generate this kind of tech. I would be really interested in this kind of thing, that we could generate this tech from YAML files. Yeah? And to have a database of questions, yeah, where you say, I want questions such and so, or with this many questions and so on. But that's not possible right now. Yeah. There are lots of things I won't talk about. So the \answer is not completely trivial in the sense that by default x squared minus 4 or minus 4 plus x squared is considered equal. Also, x minus 2 times x plus 2 will be correct. We have LTI integration, but not to the most recent version. That's on the list. There is integration with Sage, so you can do computer algebra integrated with it. All student activities are logged, and you can download it from the website. How do we use this? The classical setup is that a student obviously just needs a browser and goes to the web server, and he has everything. An author typically would need a LaTeX installation, a Git client, an editor, a GPG key, because if he wants to publish something, he has to authenticate. Not everyone can publish. There is a Cake program, which is a joke on Make, to build the HTML and the menus and so on. So this is a Chimera thing. And he needs a browser. What's then the procedure? You git clone the course, you edit your LaTeX code, you commit, and you bake the whole thing that compiles everything. You frost it, that makes it a fixed version, and then you serve it, and it gets published on the website. Yeah. These are inventions from, I think, Jim or Bart, one of the two at least. We at Leuven changed this procedure by using Docker. So people do not use their local tech installation. They can, but they should not. And the Docker contains both Cake and tech. Yeah? Gege is important to have in Docker because it was a pain to get installed. It's written in Go. It depends on all kinds of things. You have to compile it and so on. So this problem is solved by using Docker. So the fact that this disappears is really more important than what it looks like, but even more, this we also don't use anymore because we use it like this. Author has Docker. He clones, edits, commits, and he git pushes. And as soon as he git pushes, he arrives at our KU11 repository server. There with actions, everything is built, checked, yeah? And it gets served. So also the GPG key disappears now, which also is a pain. Yeah? And validation and authorization is now done on the Git server. Those who have push rights can publish. Those who don't, cannot. Yeah? I told you that there is money since beginning of this year. So what's high on the list is accessibility, a great performance, a great database, so that all the grading, which now is sent to the LMS, can also, it will still be sent to the LMS, but you will also be able to use it without LMS, and the grading will then be inside Chimera. It will have LTI support. There is TUG in the browser. People who've never seen this should go to this URL. It will be on the last slide. It's a system by Jim to do TUG in the browser. That means you have a TUG code, you push compile, and you get a PDF in 1 second, less than 1 second. Yeah? It is not overleaf, it is not running on the server, it's TUGing in the browser. This might or will be integrated in Chimera. We will improve the documentation, and so on. Good news for people who have some free time. Bart and Jim have grants from $500 to $5,000 if you think you can contribute something useful. Are there questions?
And it's not in binary. Okay, so we have just a couple of minutes for questions or comments. Yep. Marcel?
One question. You mentioned that you generate two different kinds of PDF output. So you generate two different kinds of PDF output, once with answers and once without. Did you consider also generating a version where optional content is used so that you can interactively show the answers in the PDF file?
We have not looked into interactivity in the PDFs. So in the PDF, it's in there or it's not, but I also would be very interested in that because I did not show it, but we can have the theorems or remarks collapsible or not. Yeah? Also, this thing only works in HTML. It will be very relevant to have this in the PDF, indicated at least that this is a remark that by default is collapsed because that means something, namely that it's less important.
A question from Luigi from YouTube chat. He says, impressive. I agree with him. From GitHub, I see that Chimera LaTeX master uses PDF LaTeX. Does it also work with Z LaTeX and or Lua LaTeX?
I've never tried it. It uses, so the whole HTML conversion is not done by us being Chimera, it's just Tech for HT. So I have to ask Michael whether the Tech for HT will work. Yeah, voilà. So it should work, yeah. But we will have to look into it. Yeah.
Hi, thank you for the talk. I just looked at tech in the browser. Do you know if it is done with WebAssembly? Yeah. Okay, thanks.
So it's not really magic, but it looks like magic. The first time I saw it, I couldn't believe it.
Okay, I think we'll wrap it up here and move on to our next talk. Thanks again to Wim. So our next talk is by Sarah from the University of Graz.
Hi everyone, so nice meeting you all in person. I've already heard today that I'm a little bit like Miss Colombo. Lots of people have heard of me, but nobody was sure I existed. Today we know I do. So I want to take you on a little journey into the field of digital humanities. You may know, or some of you may know, or be aware that there is a certain intersection of the LaTeX community and the digital humanities community, although I think I'm the only representative today. So, yeah. I wanted to, first of all, tell you what the digital humanities are. Usually I have to explain what LaTeX is, but this time it's the other way around. Yeah, and so I want to ask, basically, LaTeX exists in the digital humanities, but it's not used as much as it could be, and I'm wondering why that is. Maybe I'll have some answers. And I'll show 3 use cases of where it is being used in the field. 2 are pretty simple, which is conference proceedings and printed books, but the 3rd case is maybe the most interesting, and that is print versions for digital scholarly editions. And then I'll finish with the challenges and how we can maybe popularize LaTeX in the digital humanities. Yeah, so I said that. So first of all, for all those of you who haven't heard of the digital humanities, it can be kind of hard to imagine what that really is. Also for people in the digital humanities, because it's a difficult question, no one knows, and there are rumors that we don't want to define it. So I gave this pragmatic definition, and that is, digital humanities means using digital methods for humanities data and to answer humanities research questions. And so you have a bit more of an idea of what that can entail. There's also this tripartite distinction of different areas in the age. One was called Humanities of the Digital by Camille Roth, which is kind of like media studies, so thinking about media using humanities theories. In my experience, that's very much present in the Anglophone area and is not really the primary focus of my flavor of the age. I think maybe some in my flavor of the age wouldn't even be so aware of that part. But I think that's what many people believe digital humanities is, basically internet philosophy or something. Something that's in fact very important is the digitized humanities. That means you do humanities things, but in the digital realm. And that doesn't mean just using Microsoft Word. We're hoping they're not doing that, but they are. Basically, it would be doing what humanities people would have done anyway, such as creating editions of historical texts, but they do it in the digital realm. So that would be modeling, annotation, and maybe using bigger corpora and more linked corpora than before. But it's not fundamentally different. And then there's the computational humanities that are very much on the rise right now. That means applying computational methods to humanities data. For example, this would be computer vision, large-scale text analysis, which I think for a computer science person is maybe not that large, and you would refer to it as text mining, but we call it distant reading, although these terms are under much debate. So basically, machine learning for humanities data. It proves surprisingly difficult because humanities data are kind of hard, and usually the algorithms are not made for humanities data. Yeah. So I came up with 3 use cases for LaTeX in the digital humanities where basically LaTeX is already being used or could be used. One of them, obvious one, is conference submissions. It's quite pragmatic, but doesn't really pertain to the research topics themselves. So you could say it's the same for any discipline. Another thing that I once took a personal interest in because I was helping someone was archaeological catalogs. So humanities people for the PhD thesis, for example, often compile catalogs. And especially in archaeology, these have many images. So Microsoft Word doesn't do them so well. And that's why LaTeX would be very good to use, although it's not very common. I once wrote a blog post that basically showed how to use a CSV data to automatically create such a catalog. This is in fact extremely useful, but I still don't think that anybody picked it up despite the ease of use. And what I'm mainly going to talk about today is print versions for digital scholarly editions, and in case you're wondering what that entails, I will also talk about that. So just a quick word on the conference proceedings. So, for example, the Computational Humanities Research Conference, I've already mentioned computational humanities, it's this field on the rise that is, it is digital humanities, but kind of leaning towards computer science. And so this has actually been criticized. Some people in the field have been complaining that this conference only allows LaTeX submissions because it's seen as exclusionary. LaTeX is not necessarily something people in the humanities naturally kind of know or learn in their undergraduate degrees like they do in the sciences often. And so there actually is a discourse in the digital humanities. Do you have to be able to code? Is it fair if the digital humanities distinguish themselves by being very technical? And so this is a kind of loaded discourse. So I agree that not all people in the digital humanities need to code, but I don't really see how LaTeX has to take the blame. I've written a little bit about that, and maybe I will in my proceedings contribution as well. I think people are feeling kind of alienated by LaTeX because there is a bit of hard feelings towards the computer science community that is seen as kind of exclusionary for people who come from the humanities. But I don't think that has anything to do with this community that I would assume most digital humanists don't even know or aren't even aware of. I think there are many pros to doing this. First of all, you outsource typesetting work. Maybe to also link back to what Boris has been talking about with the decolonizing and so on. There are many discourses like that in the digital humanities as well. So one question is it actually a good practice to outsource things to the users, for example, especially if corporations do that, then of course they're using the users as workers basically and then making a profit from the data they create. But since in this case it's a small community effort, this makes sense because it just saves money, but places a burden on the editors, of course. I think humanities scholars can easily learn LaTeX. That was what I had been trying to communicate with my blog. You might know about it, the LaTeX Ninja, although I'm a little embarrassed that I don't really blog that much anymore, so I'm trying to revitalize it every once in a while, but I've come to the point where I'm not promising anything. But I do think it's easily accessible to all humanities people if they're using it essentially as a markup language, and I think that's mostly all they need, so not the level of LaTeX use that is present in this room, basically. Yeah, but this also leads to fast open access publication of proceedings, which is, I think, very important for early career scholars to have things out fast. This is another phenomenon that maybe you aren't aware of in the computer science fields or sciences, is that humanities publications take very, very long to get published. Especially if you work in the digital humanities, they might take so long that everything is obsolete. So of course we can't have that, and I think LaTeX is really helpful in letting us publish faster. Then young people can have the publications on their CV. It's out in good time so that it's not obsolete, and I think there are many good things about that. Also, it doesn't rely on exploitative publishing practices, for example, not publishing open access or publishers taking lots of money or making money on articles that people are writing who are not getting paid for that. So that's, I think, basically why LaTeX can be useful politically. I've already mentioned this other topic and the big title of archaeological catalogs, but of course it's more generally about physical books. So I think this is a discourse that maybe hasn't touched you as much as other areas or fields have been touched, but there have been these predictions that print is going to die out. And I think now we can be confident in saying that this is not the case, and it seems unlikely to occur in the near future. And I think this is due to a reason that is very humanities to point out, and that is that books as material objects have value, and books function as cultural capital. I don't know if you are aware of this trend, but for example, there's the book talk community on TikTok, where people are basically, if you say it in very abstract terms, they're gaining cultural capital or status from the books that they read. Or celebrities, for example, have book curators, so they pick out books that celebrities are photographed with. So actually in this time of visual media, it seems that material physical books have regained value in a way that we wouldn't have expected, or people that made these predictions wouldn't have expected. Yeah, so in the humanities also, books endure. In fields like archaeology, as I mentioned, it's still common to compile these extensive catalogs of findings, and they contain lots of images, and I think I don't need to get in so much detail about this for this audience, but if anybody who's watching the video in the future wants to know, they can look at these slides in more detail. You know why LaTeX is great, I guess. So I want to go to my third use case, and that is print versions for digital scholarly editions. So, in my opinion, in this second part of the digital humanities that I mentioned, the digitized humanities, digital scholarly editing is a very important field. There is a big community of this. This has given rise to the digital humanities, basically creating editions of books online and based on XML data. So you could say it's one of the core fields of work in the age, at least it is for me, because in Graz, where I'm located, this has been a dominant focus for a long time, even though we can also feel that people are moving to more computational methods. So my diagnosis is that digital scholarly editing has been and will continue to be a core task in the digital humanities, and thus LaTeX will continue to be relevant and remain relevant for the DH as a field. So, digital scholarly editions use TI XML as their standard. So this can allow us to produce print versions. It can also allow us to produce web versions, which is what usually is being done. But basically, we always have the option to produce a print output using LaTeX, even when the primary intent of the publication is not to publish in print. So we can use these TI XML data, transform them via XSLT. Maybe we even employ large language models to generate LaTeX code. This is also a big discussion in the field. Will digital humanists have to be able to code in the future? As I've mentioned, this is generally a question, and of course with the advent of large language models, even more so. And I think this is very relevant, but so far kind of underused as a use case. Because, in fact, many humanists like to print things out. They want to work with paper. Often these texts are so dense that you want to work with them and read them in a printed out format. So it's great to have a web version with all the advantages that come with it, so there's no limitation, because of course print is limited. It's expensive, and you have to think about what really has to go on the page, what needs to be omitted. That's what people like about web versions, that they don't have to make this choice. But of course, yeah, print is still useful. So, as you may know, there's this RelatMag package that is wonderful as a tool for this. Yeah, so I'm not sure how familiar people here are. Of course, you're familiar with XML, but the text encoding initiative, is that also well known here? Okay, so I don't need to go into this. Just in general, it supports different types of texts and also critical apparatus. So just as a mini XML primer, in case you don't know, I put a minimal example on the slides. This is TI XML. The root element is called TI. It has a TI header and a text block, and in this text block you can do lots of semantic encoding. And in case you aren't aware of what a critical apparatus is, a critical additional apparatus documents variants of a text in different witnesses of textual transmission. So for example, Cicero text has been transmitted in many different manuscripts, and if you want to make a definite edition, then people would compare all these manuscripts, say what the differences are, and make a scholarly argument about which version is best, or probably closest to what Cicero wanted to say, if that's even possible. So these things can be encoded or represented in LaTeX using the RelatMag package. And I just put one example on the slides in case you haven't seen what that looks like. You have the main text and then the critical notes. And so this, of course, as I said, can be done in TI, but it looks different in TI than it does in LaTeX, of course. So in TI, critical apparatus is encoded with app for apparatus, RDG for reading, or RDG group for reading group. And then there's also lem that allows us to put in text that is not contained within any witness, but that I want to put in the final version, basically. And there are two code examples of what that can look like. Basically, you have different versions of the text, and there are no annotations around the text that is the same in all versions. Then, to make this even harder, there are 5 different ways of representing this in the TI. First of all, because they have different advantages and disadvantages, but also, I guess, yeah, humanities people want to be very precise, and this is necessary, I guess. And these options, just so you've heard of them, they're called location references plus internal or external, double endpoint plus internal and external, and parallel segmentation. So of course, if I want to transform something from any generic TI document to this LaTeX version in RelatMag, I have to consider lots of cases, basically. There is, in fact, a transformation tool already, and this is from the TI apparatus toolbox, TI CAT. And this has the functionality, as basically a web tool, that you upload your TI document that contains apparatus, you set parameters via a web form, and then it will run the TI to LaTeX transformation and give you a PDF. This is great because it's usable if you don't know any XSLT, basically. But of course, it's also limited in terms of what you can customize. And I think if somebody put in all the work of encoding their text, they probably want to make custom changes. Anyway, I mean, humanities people always want to make custom changes, I guess. Yeah, so there is this XSLT template, but it's quite complex. I was once asked to teach this to someone, and then I looked at it myself and realized, wow, this is very, very complicated, even if you knew both the TI and the RelatMag. So what I did for teaching purposes was to create a simplified XSLT document, and which was basically the result of the first and sadly thus far last in-person LaTeX Ninja workshop that I gave in 2022. Maybe I'd have to get back into this, but this is for the future directions, maybe. So this was supposed to help learners get used to this XSLT, but it's not that easy, especially for someone who's not into technology as much as maybe people in this room. Yeah, so we get right into the challenges and my attempts at popularizing LaTeX in the DH, as in future attempts. So some of the challenges that I haven't mentioned yet are that humanities scholars or digital humanities scholars seem to have a difficult relationship with print, even though humanities scholars like print. I think this is something to do with how the field originated by differentiating itself from the classic humanities. And I think despite it being very useful and practical and having obvious advantages, LaTeX isn't really used that much in the field. I think that's also why people were actually turning to my blog, even though initially I thought I didn't really know that much about it myself, but there really just weren't that many resources. I think opportunities are, as I mentioned, providing XSLT to LaTeX transformations that can produce print outputs from TI data, especially given that an alternative provided by the XSL language, XSLFO, was discontinued in 2012. So if you want to have a print output from TI, LaTeX transformations are basically the only option. I want to also mention one more example from my own DH work in the past. I've worked on this project. It was called Graf, the Graz Repository of Ancient Fables, and this was kind of a digital scholarly edition of fable texts from antiquity for Greek and Latin classes. So we worked together with students, asked them which vocabulary do you want explained, and came up with a simple edition that would be interactive, but it also crucially had print outputs because, as you might know, teachers often want to print things out and want to do them with their students. And since the web portal actually contains all the solutions, they did not want to hand the solutions to the students, so we needed to print it out. And so I created these worksheets using LaTeX. But what you might have to know about this is that we work with GAMS. This is the Humanities Asset Management System and XML-TI-based platform for archiving digital scholarly editions. So it's a repository, but it is also a platform for making the editions available, basically. And it generates all representation from this data on the fly. That means the only thing that gets archived is the XML-TI data and maybe some metadata, but everything else, the web page, even RDF, is generated on the fly, and also this would be the case for PDFs if people are using it. So there I encountered lots of issues, which was that the only thing that you were able to get out of this was basically finished PDFs, or if there were errors, nothing, and very cryptic error messages. This proved very cryptic and time-consuming to fix, and sometimes errors occurred even in documents that were previously tested outside of this environment, and it really didn't provide lots of opportunities to look into what was happening. So you had to run it locally. That was kind of contrary to the system's intended automation. Then also I wasn't able to fix errors locally because it was supposed to generate automatically without mistakes. And that just proved way too time-consuming. And then recently they're developing the next version of this system, GAMS 4. And the previous lead programmer, my former boss, went into retirement, and he was the one, I think, supporting LaTeX. And ever since, I'm the only remaining supporter, basically, in the team. And this new version didn't even carry over the LaTeX features, so I didn't even have the opportunity to access the LaTeX code generated by the XSL transformation. And of course, you can get mistakes from LaTeX not compiling, like LaTeX internal errors, but of course, you also have errors from a faulty style sheet. So there are many different sources of errors that are very hard to debug if you can't even see what code you produce. Yeah, so far the team has agreed that I should come up with ways of making LaTeX more palatable or interesting to them, and to use static uploads in the future so that we could use LaTeX transformation, compile everything basically locally, and then upload PDFs and archive them in the system. This is kind of contrary to the system's intention, because of course PDFs are bigger to archive than XML-TI files, but it seemed programming-wise, yeah, the programmers are also kind of stretched too thin anyway, and since apparently only I am interested in this, I can understand that they want a programmatically simple solution. So what are my proposed solutions? I promised the team I would create a tutorial. I don't know if you're aware of the programming historian. So I was thinking about writing a tutorial that says, what is LaTeX? Why should people care about LaTeX? What are some practical use cases, basically what I've been telling you about? And then especially go into this digital scholarly editing use case and provide a step-by-step guide to transforming TI to LaTeX in the hope that with more teaching resources available, this would be more interesting. And for my team, I already said we're probably moving to a static workflow, so no more on-the-fly LaTeX production. Yeah, and I think as a last thing that I'm supposed to be doing, maybe you have some suggestions for this, is to figure out when and how print workflows make sense or are needed, because it does seem that this is not being supported as much as I would like to, or like to see it supported, because people just don't see why they need it. Yeah. So that's it from me. I have a few references for you, but I don't think you need that to read that. We can look at this if you want after this. And yeah, thanks for your attention.
Yeah, it never ceases to amaze me how people will reject LaTeX as being too complicated, but constantly fight with word processors and accept it as a fact of life. LaTeX will never change the borders in your table if you delete a line. So, questions for Sarah? I'll go with this for this one.
Hi, thank you for the talk. I'm sorry if I missed this, but my understanding is people in your community, some of them at least find LaTeX intimidating or not as useful as you think they should, but they produce documents in TEI, this XML format. What is the authoring tools that they use? Like how do they create the TEI XML files in the first place?
Partially automatically. So for example, I'm not sure if Pandoc supports that, but there are similar tools. It's called, for example, the TI Garage. That is a conversion tool, so you could use basically a docx file. Then what also could be is that people from the humanities are producing it in Word using formatting macros, and then we use this TI Garage thing to extract that into XML and write a transformation to get it into TI. So there you would need someone like me who does this mapping, or you could just directly write it in TI. I think that's more what we're trying to get to. When I started out, we used to have this Word macro to transformation thing, but they used to create so many awful errors that were so horrible to debug, and it never worked automatically like it should. So we're trying to get them to just encode it manually. They use editors like, for example, Oxygen XML, because often, you know, it's like interpretative work, so it's slow work anyway, so they might as well put the pointy braces themselves, basically. That was the question, right?
Yeah, right, thank you.
The tools.
Anyone outside of Boris?
I ask a lot of questions mostly because I have a task of relaying YouTube questions. But this question is not from YouTube, this is from me. There is another, okay, first, we all love your community in our LaTeX community, we are very friendly. But there is another community besides us, which obviously is important for you. And this community of people who work on Unicode, on open-time fonts, and so on. And I happen to know that there is a lot of work of making fonts for ancient languages, for even many thousand years ancient, and work for small languages, for small number of users, and so on. I wonder, do you need some help from us to create packages for you to use with the fonts, to use with things for archaeological work, for historical work, for work with that? So could you formulate what do you want us to do for you to interface with them?
Oh, that's a great question. It takes some work away from me, and that's great. Lots of opportunities for collaboration. So what I always need is the Unicode for alchemical symbols, because I work with alchemy. So in a 2009 project, William Newman made sure that the most important ones got integrated in Unicode, but I think they're also not always easy to represent in the font. So that's, of course, helpful, but I think that most of them actually can already be represented in LaTeX. It's just a little clunky, from what I know. And then I think medievalists are using font like Unicode, like with a J in front of it.
We recently put this into TechLive, so I just was happy to see so many interesting things you can do with this.
Cool. Yeah, thanks. I think people should also comment in YouTube if they need any fonts rendered in LaTeX, and the community will be happy to, it seems. Yeah, thanks.
I thought you had a question. You have a question?
So we are using TEA XML heavily in one of our local language publishing project. The local language is Malayalam, which is used in a state called Kerala, the southern states of, one of the southern states of India. So how we are creating the TEA XML is, we get the author's document and we convert into LaTeX. From there, using TechForest, we create the XML. From, as we say, the XSLT is, we use XSLT to create the tech and the print version as well as the HTML version. The HTML version is all even the PDF version we create in such a manner, it can be read in mobile devices also. We will create various forms of PDF because the phone width will be one and the iPad width will be different. So to make it comfortable to read in mobile devices, we create different PDFs as well as the HTML. So if at all some help is required in the XSLT part, we are able to do that. Because we have been using XSLT for the last several years because we do a lot of mathematical this help to the Elsevier science.
Thanks so much. That's very helpful. And it's also great to hear that other people are also still using it. Because there's some rumors in the community in the digital humanities that with the large language models being very good with Python, that maybe XSLT is going to become obsolete. I'm not sure. Maybe not.
You really have a question? Yeah. I think I saw Python is harder than learning LaTeX, which shocks me as a software engineer because Python was literally one of the most easiest programming languages I've learned in the years. And I did like 6 years to find out that I have to use the package manager of TechLive itself instead of the package manager of Ubuntu. Yeah, so you also talked about outsourcing. Well, Python isn't the thing, well that's sufficient, right? There are a lot of Python programmers. But for LaTeX, that isn't so well taught in schools, like maybe someone has done his thesis for its PhD. But what I saw in, well, at my bachelor, for example, LaTeX isn't even known only by few teachers. Despite the fact that it's being well documented. But I think you'll have to give it some time for schools to pick up, to educate the people like doing great things with LaTeX. I mean, we're all around from the world and we're not with that many. So, yeah, I don't know how you're gonna gain that knowledge.
Okay, let me first explain what I meant with Python and LaTeX. So I meant using basically LaTeX like most humanities people would use it, kind of as a markup language, but not actually basically programming it. So that's where this analogy comes in. And so what was the second question?
Yeah, so yeah, you stated as a question, I think, in your presentation, and I was wondering how are you going to cope with the schools not teaching LaTeX anywhere, as I'm aware of.
Yeah, I guess like schools don't necessarily need to teach it, but if we have good online teaching resources, at least the people who want to can learn it. That's how I would approach it. To give some more tutorials that are maybe understandable if you don't already have lots of knowledge, because I think documentation is great. I'd already argued that, I think, in some point. But I think for someone from the humanities with no previous knowledge, documentation is not understandable because they lack some basic tech. I would call it like the tech privilege or being aware of how the tech world operates. So that's also something that I feel can maybe bridge a gap, the kind of language barrier in terms of we don't talk about the same things or there's some basic blocks of knowledge missing. Thanks for so many questions also.
Maybe one last one as a comment. I guess you are aware of learnlatex.org. I was just wondering whether it makes sense to think about taking this kind of approach with a twist for, I mean, this is focused on sort of the standard way of thinking about LaTeX, but there might be sort of a path that is more tuned to what you would need in your community. I mean, on the whole, that is already a good starting point, because within a couple of hours you can get anywhere and you get it live. So if there would be something like that, sort of in parallel, maybe, or as a side theme, just a thought.
Yeah, thanks, that's great. I will try to take all that into account and make sure I publish this in many different sources, like the Learn LaTeX and the Programming Historian and Tugboat. I will be very busy this summer. Thanks so much for all these comments. It's really great.
Thank you. Break until 4.